Welcome back, everyone. We're here for day 3 of the completely free AWS Certified Solution Architect Associate 2023 course. My name is Michael Gibbs, and I'm the founder and CEO of Go Cloud Careers, and I'll be your instructor throughout this week.
Hey, Mike, Mr. Producer here. It's day 2.
Which day did I call it?
You said day 3. You were too
Okay,
excited. You're way ahead of yourself.
it's day 2. Apologies, everyone. There's been a lot of things going on in our world right now, so even I get my days confused periodically. So day 2 of the AWS Solution Architect Certification course. Some of the things we'll cover here will help you with some AWS Solution Architect interview questions, and this is a complete AWS full course tutorial and free AWS training, and it's a free AWS certification course online. So with this free AWS course, we're going to help you pass the AWS Certified Solution Architect Associate. The exam, just so you know, is SAA-CO3. It used to be the SAA-CO2, but this is a more modern exam, the SAA-CO3. And we're going to have a lot of fun here. Now, I want to make sure that you all know of some things we're going to do to help you. I want you to all sign up for the How to Become the Ultimate Cloud Architect or How to Get Your First Cloud Architect Job webinar. It is tomorrow evening, and we will tell you everything you need to do to get your first cloud architect job. Certifications may be 3 to 5% of what you need to do, and I want you to all get these elite cloud architect or AWS solution architect jobs or Azure solution architect jobs or Google solution architect jobs. I want to know that you've got the best cloud computing career because that's what we're all about. So join us tomorrow on the completely free on the completely free How to Get Your First Cloud Job as a cloud architect. It will be well worth your time. And we'll be on a platform where we can speak live and talk to each other so we can make sure we can answer any questions you have and help you build the best cloud computing career. While we're at it, I want you to completely download the completely free AWS Certified Solution Architect Associate and Professional ebook and labs. We're going to be focused heavily on the concepts here. Why? Because you get hired based on the concepts. If you're a cloud architect or a solution architect, guess what? You design, present, and sell. You don't even touch the technology. But it's more than that. If you're a cloud engineer, you're going to be performance tuning. And the challenge is knowing what to do, not how to do it. How to do it is nothing. You can go straight to the AWS website, and they've got complete step-by-step instructions. So in the labs, which if you can download, you can watch on your own time. You can practice those as well. But guess what? We're going to focus heavy on the concepts because that's what it's going to take to win the interview. And that's also what it's going to take to be able to know how to do any of these jobs. I've interviewed 1,000 AWS certified people that took the courses out there, which is why we do ours free. And while they all knew how to configure, they didn't understand what they were doing and why they were doing it, which meant they were unemployable. And I want you all getting the best jobs because we're all about getting you all cloud hired. So make sure that you attend the completely free How to Get Your First Cloud Job webinar and get the free additional AWS resources because I want you all hired, passing your certifications, and having the absolute best career. If you missed day 1, don't worry about it. You can catch day 1 on our YouTube channel. Each day stands alone. And go back and watch it tonight and enjoy day 1. And today we're going to cover day 2. I know I called it day 3, but it's really day 2 today. I was all excited about all the things we're doing this week. Let's face it, that's just me. I love doing these things. Many people ask us which AWS certifications to get. As a rule, the AWS Certified Solution Architect Associate is the starting point. Now, which certifications you should get is completely dependent upon the career you desire, but the AWS Certified Solution Architect Associate is a basic intro to cloud computing, and that's what we're going to do. So let's start talking about the AWS Solution Architect training because this is an AWS Cloud Computing full course, at least as it pertains to passing the Certified Solution Architect Associate exam. So yesterday we talked about the orchestration of the cloud and getting our data to the cloud and storage. But today we're going to begin by talking about computing on the cloud. But before we do that, can you guys all give me a hashtag that says AWS Solution Architect Associate Certification? in the chat box. And that way I know you're awake, alert, and oriented. I'm a medical person, and we medical people like to know that the people know where they're at. That's why when somebody falls down, we say, do you know what time it is? Do you know who the president is? Do you know where you're located? So I like to know that you're all awake, alert, and oriented. As in medicine, we would call ×3, which was my old fun career, internal medicine. Before I went into tech 25 years ago, and let me tell you, I will never go. I've never looked back, and I love tech. It's the greatest thing. So for all you guys that are putting Cisco over there, I love that name. I spent about a decade at Cisco. AWS Solution Architect certification, fantastic. AWS Solution Architect certification, I love it. I'm seeing all this AWS Solution Architect certifications out there. So I know you're awake, I know you're here, and I know you are ready to go. Love it. So fantastic. And if you're a nurse, you can, that's wonderful. I was a nurse, and then a nurse practitioner, and I was a firefighter, paramedic even before that. And healthcare people become great architects because they're used to asking people questions, and they're used to communicating with people. And for the nurse that's here, if you ever had to sell your patient into taking a medication, which I know you have, or following healthy lifestyle guidance, guess what? We do that with technology all the time as architects. So let's have some fun, and let's get into the content. So a cloud or cloud computing is nothing more than renting space in somebody else's network and data center. That's it. It's somebody else's data center that you rent space in. And again, what is involved in these things? It's routers and switches and servers and storage, physical load balancers, firewalls, intrusion detection, intrusion prevention systems, some cabling. That's it. That's what the data center is. And guess what the cloud is? It's renting space in that. So when we talk about computing, guess what? We're going to be talking about the same thing, because cloud computing is nothing new. First cloud I worked on was in 1996, and it has changed very little, even though the marketing people does. So renting space in somebody else's. Eva Doike, I am thrilled to see you here along with Lady Guitar. So let's talk about computing. In the data center, we've got these physical servers, everybody, okay? Physical servers. And in the cloud, they still have the physical servers. Now, in our data center, typically speaking, we take these servers and we either put VMware on it and virtualize these servers, or in today's modern world, we either use Nutanix, which is one of my favorite hybrid cloud solutions, or we use IBM OpenStack, which is more commonly used than Nutanix, but they're all great private clouds. And what do these things do? They enable us to take our servers, virtualize these servers, and reuse them to full capacity and scale up and scale down, just like the cloud. And when you're on the cloud, guess what? You still need servers. Even serverless uses servers. It's a marketing term, no matter what, you're on servers. So in the data center, we call it a virtual machine. And guess what? What are we going to be talking about today in the cloud? Virtual machines, nothing's new. So if you've used a VMware virtual machine, or a Microsoft Hyper-V virtual machine, or if you've used a Citrix virtual machine, or if you used a KVM or QEMU virtual machine, guess what? We're going to be using the same identical stuff with a new name on the cloud. Like the Who song, meet the new boss, same as the old boss. It's the same stuff. So AWS is going to call your virtual machines AC2 instances, because that's what they paid their marketing people to do. Google is going to call them compute engine instances, and Azure and Oracle are going to call them virtual machines, which is really what they are. They're a little more, buy a glass of water, they call it water, not a hydration system. Whereas AWS has to throw the term elastic and come up with all kinds of funny names for everything. So when you pick virtual machines on the cloud, how do you size them? The same way you've done it for the last 2 decades in the data center. You size it based upon CPU cores. You size it based upon DRAM. You size it based upon storage capacity and performance, which you're typically going to be using block storage for, like we talked about yesterday, unless it's a dedicated server. And we size them based upon networking performance. That's it. So if you need to figure out what you need, how many cores do you need and how much DRAM do you need? Now, I want to make it very clear. Bare metal server performance like the data center and cloud server or any virtual machine performance is not the same. For example, if we use my favorite servers right now, which are using these beautiful AMD EPYC processors, and we have a server that has 128 cores, and 4 terabytes of DRAM, that's 128 physical cores. Physical little CPU chips on the CPU. Now, when we deal with these servers, they can do something called hyper-threading, which is where then the core can split into multiple cores. Now, if you've got a car that can drive at 90 miles an hour, and you split it into 2 cars, each car can drive 45 miles an hour. Same thing. So in the data center, if you've got 128 physical cores, they split into 256 virtual cores. So when you buy a 128 core server, say from Dell or IBM, you're getting 128 physical cores. When you buy a 128 core server on the cloud, you're getting 128 virtual cores. So it's basically 50% of the performance of your actual server. So keep that in the back of your mind. Now, the reality is, in many cases, those virtual cores aren't being used, so it's closer to the performance of, say, 75% of the actual server. But got to keep that in mind. Physical cores in the server and virtual cores. So when they're selling you virtual cores, they're not exactly the same as physical cores, and you're going to have to test and kind of get the performance that you actually need. Now, the marketing department decided to take something basically that is simple and efficiency and come up with a bunch of silly names. Look, here's the reality. If I need a server, I'm going to basically see which has the right cores, which has the right DRAM, and which has the right network performance. And I don't care about any of these silly letters. I'm going to Google it. But, you know, AWS is pre-made servers specifically for pre-made uses, which may or may not match your needs. And they basically came based with ARM-based workloads. ARM-based workloads are great for web servers. They're super low power draw. They're not the highest performance thing either. They've got your compute optimized, which you can work with, for example. They've got your G-based servers, which have GPUs in them. Basically, use them for machine learning if you're going to use build your own machine learning environments using, say, PyTorch, TensorFlow, or any of the machine learning tools that you might use. You've got your I's for high-speed storage. You've got your M5 for general purpose, typically use it for databases. Your M6, again, are general purpose, but more application servers or gaming servers. You got your R series, which are really memory optimized when you need lots of memory, like a cache, for example. You got your T3, which are basically burstable, which basically get a little performance and you can burst a little more, add a little capacity when needed. Test environment, realistically speaking. And you got your X1s, which are really low price for DRAM when you need these high servers. Huge in-memory databases, for example, you need 4 or 6 terabytes of RAM. These are the systems that you're actually using. So kind of keep that in the back of your mind. They've pre-made these, and they may or not be exactly what you're looking for. But really, you're going to be sizing no matter what these things say based upon CPU, DRAM, and network performance. Now, realistically speaking, your traditional virtual machines on AWS support Linux and Windows. It's like the same as the data center. But you're going to stick on it, whether it be Red Hat, Ubuntu, it's there. Amazon Linux is an offshoot of Red Hat Linux, just like Oracle Linux is an offshoot of Red Hat Linux. The most common operating system on the cloud is not Amazon Linux. It's Ubuntu Linux, which is what most people use, but you can use any that you want. Any which your applications are going to perform better. Typically, machine learning applications, for example, are better on Ubuntu. Super stability things often are better on Red Hat, but it's up to your systems administrators to determine what's the best operating system for you. For the most part, you can build a plan. I need this many Linux servers, but somebody's going to get closer on the Linux side. The Linux engineers are going to help you select that. Now, AWS also has an EC2 instance that runs the Mac operating system. They call it mission critical, but it's not mission critical. And here's the reason why. It runs on a Mac Mini, and a Mac Mini is not a mission critical system. It does not have a Xeon type CPU or an EPYC type CPU. It does not support error correcting RAM. And it doesn't have any fault tolerance in it whatsoever. So it's not mission critical, but it's great, those Mac EC2 instances, for, say, an application developer that needs to compile code and they don't run a Mac or use a Mac normally. You can use pre-built virtual machines like many people do, or guess what? You could use a custom virtual machine. You can create it just like you would in the data center. Pre-built virtual machines are available from Amazon as a machine image. A machine image is basically an image of any server, no different than a VMware image of a server that you've been using for decades. Azure has their own images. Oracle has their own images. Google has their own images. And typically your machine instance is going to need a compute system to run on, and it's going to need some block storage to store your data. Now, like I said, you can build them. You can use a stock thing like the stock operating system and build on top of it, or you can buy one. So let's say you have some real security. You're not going to be using AWS WAF, and we'll talk about that when we get to the security section. You're going to be using an industrial grade firewall if it matters, say something from Palo Alto or from Cisco or from Fortinet or from Checkpoint. And you're going to be getting that from the marketplace. And it's a pre-built virtual machine, optimized operating system is fully hardened, and it's going to do with the precision firewall type services. And we can get them. We can take one of our virtual machines in the data center and convert it to an Amazon virtual machine image and relaunch it in the cloud. And that's what we're talking about. Basically, we're just uploading our servers. And we can also, just like we do in the data center, VMware gives you an environment to take a physical server, a bare metal server, and then turn that into an image that you could then run on a VMware server. We do the same thing on the cloud, no different, and there's tools to do that. So let's talk about the Amazon machine image. I mentioned it has an operating system. It's going to have launch permissions, and it's going to have a block device mapping, which basically says which block storage you're mounting to. Now, when you've got this image of a system, it's a single file that contains everything on the hard drive. It's really cool. For many of you guys that are a little older like me, if you've used Semantic or Norton Ghost, now it's Semantic Ghost, and we could take a whole Windows system, we copy it to an image, and then we could push that to 100 different computers that were configured identically. That's an image, same thing. The image is that snapshot of a machine. We can stick that in different regions. We can stick it in different clouds if we want to. Now, AWS would tell you to take that image and stick it in a different region for disaster recovery. It's insanity. I'm going to tell you why. It's insanity. You don't back up your stuff to the same place. And the single cloud is the same place, even if it's a different reason. You back it up to another environment. I wouldn't put, like, if I was worried about my bank going bankrupt, like Silicon Valley Bank just, kind of had some financial issues, I wouldn't put my money back in Silicon Valley Bank. I'd use a different bank. So if you're going to do some disaster recovery, and we'll talk about that, don't stick it in the same cloud. That's as ridiculous as you're worried about your bank putting your extra money in the same bank and hoping that the bank's okay. It just doesn't make any sense. Now, when you're dealing with virtual machines, what we're really talking about is as follows. You got your operating system. Now, if we wanted to basically set up a virtual machine to configure itself, like we've done forever, we'd write a script, typically a bash shell script. Or Windows, we'd write a PowerShell script. Systems admins have been doing it forever. We can do the same thing on AWS. Let's say we've got auto scaling. We wanted to configure our servers coming up. We can basically write a little script, mini bash shell script that, for example, AWS calls it a bootstrap script. Remember bootstrap script for your exams. And realistically speaking, we could say, update the operating system. So let's say it's an Ubuntu system. Sudo apt-get update, sudo apt-get upgrade. We could have it immediately do that. And then we could have it install our web environment. I'm an architect, and architects don't touch the technology, but I think I remember with an Ubuntu system, it's sudo apt install HTTPD or Apache. We could set that up to install the web server, for example, while we're at it. And basically, they're just simple scripts. Now, we're going to talk about the way you rent your systems. All a cloud is like a hotel. You rent a room in a hotel, you rent space in the cloud in somebody else's data center. That's it. So how do you rent it? Well, there's a lot of ways that you can rent it. And we're going to talk about the renting options. The first is on demand. What does that mean, and when would I use this? I started a new website for my cat, Cindy. I have absolutely no idea how many hits per day she's going to get. And if I knew, I would specify it and I'd get a cheaper rate. But if I don't know, I can stick it on an on-demand server. I'm going to pay by the second. And what'll ultimately happen is, if I need capacity, I'll add other servers. Now, it's convenient to not know what I'm going to pay for. So guess what? I pay extra because I don't know. So kind of keep that in the back of your mind. An on-demand instance is as follows. You purchase it, and you don't exactly know how much you're going to use, so you can on-demand. So on-demand is very useful. And even if you do know what your capacity is, you're probably still going to use on-demand. I could also say specify 5 servers and use on-demand for additional capacity. So on-demand, you're not 100% sure what your needs are, or you might scale. You pay more but for the use, but it's not always there. The next purchase or renting option, if you want to call it, is something called a reserved instance. What is this? Well, it's as follows. I know I need 10 servers with 28 cores and 128 gigs of RAM. I tell AWS I'm going to use 10 servers with 128 cores and 24 cores and 128 gigs of RAM. And guess what? I tell AWS I'm going to buy it for 1 year or for 3 years. And the longer I commit to it, the cheaper the price they'll give me. Why? I just committed to it. Then again, if you're going to commit to something, it's really no different than calling Dell and buying it for your own data center. But there's that. But when you tell them I'm going to buy your stuff for a long period of time, it enables AWS to know how much capacity they're going to need for their systems. And they'll either know to buy new servers to support your needs. And that's the way that works. So on demand, pay by the second. You pay the highest price. Reserved, and you can reserve it consistently full time, which is what we're talking about. And you pick a duration from 1 to 3 years. And the longer you commit to buying somebody else's stuff, the cheaper the rate you get. And the next thing that we'll talk about is scheduled reserved instances. So let's say, for example, I know that I'm going to be running a big batch computing job, and it's going to be every Friday, every Saturday and Sunday, and it's going to be for 48 hours straight. I can tell AWS and schedule this capacity that I'm going to prepay and commit to, or at least commit to paying, not necessarily prepay, for say 3 years. And I'll get a cheaper rate than if I used on demand. So on demand, pay by the second, highest price. Next the lowest we're going to get here, the next one of the lower prices is going to be to reserve it for 1 to 3 years. Scheduled reserve, we're going to pay more than if we reserve it constantly for 3 years, but we're still going to get a discount on our rental prices. Now, the cheapest option is something called the spot instance. Google calls it a preemptible instance. What's a spot instance? AWS usually has extra capacity, and you can bid in an auction-like manner on this extra capacity. And if your bid gets won, you get cheap access to compute power. Sounds great, right? There's always a caveat. Always a caveat. If you're using a spot instance and somebody outbids you on that instance, your system gets shut down, whatever you're working with stops, and you're out of luck. So spot instances, which are basically virtual machines that you bid on, are great if you've got something that's not super important and you've got systems that are tolerant of being turned on and shut down. But don't put anything that matters on it. On demand, highest price. Standard reserved instances where you schedule it for 1 to 3 years. One of the lower pricing options for long-term consistent use. Scheduled reserved, I want to reserve it every Saturday and Sunday or something like that. You get a discount for it. Spot instance is the cheapest, but do you really want to put your systems on something that once they get shut down because somebody outbids you and you're out of luck and you're offline? Probably not. So maybe good for experimentations and things like that. Now, we'll talk about tenancy options. Typically speaking, when you're dealing with a cloud computing environment, there's something called oversubscribe. and your stuff is spread around. What's oversubscription? Just like your internet service provider. Your internet service provider does not have enough capacity for everybody to use their stuff completely 100% at a time. AWS won't really talk about this, but their service provider, and all service providers do this, generally speaking. So if I've got 128 cores on a server, I might sell 156 cores because we assume most people aren't using them all at the same time. Now, if everybody uses their stuff on the same time, there's performance constraints. I'm sure all of you have experienced oversubscription in your life. When we all got stuck working home from COVID, I mean, I've been working home from decades, but when we all got forced working from home from COVID, and all of a sudden everybody's in their house and the kids are watching YouTube videos and somebody else is playing games and somebody else is watching Netflix and you're trying to work and your internet came to a screeching halt, it's because your internet service provider did not have the capacity for all the people that would be home at these times. So anytime you're dealing with cloud computing, it's a service provider, know they're going to be oversubscribed on their networking and their compute. But let's talk a little bit more about shared tenancy. This is standard. You rent some compute space from your cloud provider, and your stuff is on there, your competitor's stuff is on there, somebody else's systems are all on the same server. That's shared tenancy. This is standard unless you do something else about it. Now, the next thing is something called a dedicated instance. Now, this is basically where you say, Go Cloud Careers is reserving this entire server, and all of our virtual machines will be on that. We can guarantee that we're not oversubscribed this way, and we can guarantee for security purposes that nobody else is on our same server. Is there usually speaking a security risk of having other people on the same server? Not really. The hypervisors are pretty darn secure. But if we want to know that whole server is ours, we can do so. Now, what's the next option? The next option, if you really need performance, is to get a bare metal server. This is going to give you the same performance that you had in the data center. Hey, wait, I can achieve data center-like performance in the cloud. That's how you do it with a bare metal server. And on your bare metal server, you can do whatever you need. Maybe you're running an application that needs access to the actual MAC address on the Ethernet cord, or a serial number, or you need to stick a security key in that, or those kind of things. That's a bare metal server when you need access to the physical hardware. And guess what? If you've got a staff that's fully trained on Nutanix, and you don't want them to learn any of this AWS stuff, guess what? Or VMware. You can purchase bare metal servers and run your stuff directly on it. And then you don't even have to train your people in AWS, and AWS is basically transparent to them. You're just using their stuff. And it feels like Nutanix, or it feels like VMware. For the most part, it minimizes the learning curve for you to do the same thing. So now we know a little bit about the tenancy options, and we know a lot about the purchasing options. Now, there's more to cover on these virtual machines. Chris, how long have I been speaking? Because we may need to take a few questions.
Yeah, it's time to take some questions.
Let's take some questions.
All right.
And I'll quickly talk about the DevOps versus architect for about 1 minute, even though it's not related to the concept at some point.
All right. So before we take some questions, I want to ask everybody, if you like what you're hearing and seeing, hit that like button, hit that subscribe button, hit that notification bell button so you don't miss the next 2 sessions that we've got. I see we've got 344 people currently watching, but only 104 of you like it, apparently. So if you're enjoying it, make sure to hit that like button. So let's get to some of these questions, and then we'll get back to the content after Mike is finished with these questions. Why don't you go ahead and start with that DevOps versus architect?
Okay, I'm going to deal with the DevOps one as well as the Linux and Python question at the same time. They came out of Butzar. DevOps is a career for software developers, because you must be a great programmer first, who automate software release cycles. They get involved in tools like Jenkins and Spinnakers, and they are 100% related to automation, and all they are is a techie that's all day long automating software releases. Cloud architects design, present, and sell technology. We don't touch Linux, we don't touch Python, and we don't do DevOps. It has zero related to our career. They are completely somebody else's career. It's kind of the difference between an airplane pilot and an airplane mechanic. An architect is a business executive who designs, presents, and sells a technology solution. And there's a list of everything you need to know to be an architect. And we're going to talk about all of it tomorrow on the completely free How to Get Your First Cloud Job webinar. DevOps is a completely different career. Linux administration is completely different. Architects are not allowed to touch the technology if they work for AWS, Azure, Google, Oracle, if they work for Accenture, Capgemini, Deloitte. Architects design it and sell it, and present it. Cloud engineers go and build it. DevOps engineers go and build and automate things. Once it's finished, it goes on to a maintenance team called SysOps people. And once it's done that, if anything breaks, they call the technical support center, which is a different team. So now let's get back to the content. What's the difference between bare metal, physical, and virtual server? A physical server is a bare metal server, meaning you call Dell, you call IBM, you call HP, and they ship you a server. That's bare metal. A virtual server is after you take that physical server and you install a hypervisor, the AWS Nitro hypervisor, the VMware hypervisor. Nutanix has a beautiful hypervisor. KVM, which is a hypervisor, I'm pretty sure that's used in the OpenStack cloud. And then you chop that server into multiple little virtual machines, which is a logical image, and that's there. In fact, let's kind of, I'll actually, I thought I had it in here, but for some reason, maybe I don't have a picture. And that's such a good question. I'm actually going to draw it out for you. Give me a minute real quick. Okay, so let me do this. I'll actually I'll go back to my whiteboard because I love this question and I want you guys to understand it. So let's go to scene 2. This is not, okay, this is tenancy options. So let me go over here. I didn't create my slide, which is really what I wanted to do. Okay, so here we go, because this is a great question. We've got a physical server. So let's say this is our server hardware. This is our server. Next thing we're going to do is we're going to install a thin layer of software. It's going to be called a hypervisor. And the hypervisor is what's going to be involved in chopping up this server to little mini servers. And here what we're going to be doing is we're going to be creating virtual machines all on the same server. And what happens is the virtual machine is going to have its operating system. It's then going to have, let me do this. It's then going to have its application set and dependencies. And that's what it's going to be like. So this could be a way, so we could have one of these on the server. And we're going to, typically speaking, have multiple. We can have another one. We can have another one. We can have another server. And we can have another server. So that's typically what we're speaking with. We've got our server. On top of that, we've got a hypervisor. And then we got all of our virtual machines. And one virtual machine could be Windows. One virtual machine could be Red Hat. One virtual machine could be Ubuntu. So what we're really dealing with is taking one system, chopping it down to another system. So virtual server is any one of these things that we're actually dealing with. Any one of these things is a virtual server. The physical server is the thing that you actually buy. Bare metal is the physical server that has nothing on it. Great, great, great question there. How often do spot instances get shut down? It's based upon utilization, bidding, and capacity, and it changes every single day. Is it worth the risk? It depends on what you're doing. If I'm doing a test, yeah, it might be worth the risk. If I want to test 1,000 routers running on virtual software and stress them out for a period of an hour, yeah, it might be worth the risk. Am I going to put something important on it? Of course I'm not. So everything with architecture is based upon business is based upon business requirements. 100%. There's no best tech ever. There's what works. And yes, there's entry-level cloud architect roles. I get people hired every day with zero background whatsoever. Are any good use case to spot instances? Yeah, if it doesn't matter. If you're looking for cheap compute capacity and it doesn't matter, yeah. But for anything real, I wouldn't be using it. Test environments are beautiful. So a dedicated instance is different than a dedicated host. A dedicated host is a bare metal system that you can do anything you want with. Install VMware ESXi, install Ubuntu Linux directly on it, have physical access to the hardware, and be able to use all the cores at maximum capacity, including physical and virtual. A dedicated instance is basically running the AWS hypervisor, and you can create all your virtual machines that are specifically AWS virtual machines all there. So kind of keep that in the back of your mind. There is a difference. Can you use VMware, AWS, VMware, and other platforms like Google Cloud? Well, what you can do is you can create your virtual machine, which is what I would. And then I would have that converted into an AWS virtual machine image. And you can have that one converted into an Azure virtual machine image and another one Google. And then you can run 3 different clouds on it. So yes, you can convert one to the other, but I would create my own virtual machine the hard way, the original way, like the VMware, and then move it. Is VMware a hybrid cloud? Running VMware and connecting to a public cloud is a hybrid cloud, just like running Nutanix and connecting to a public cloud is a hybrid cloud, just like running OpenStack and connecting it to a cloud is a hybrid cloud. What are the use cases for a dedicated host? Dedicated host. I want 100% total control. I want to put VMware on my system, so I don't have to deal with any of these AWS management consoles, and I want to do it my original way. Dedicated host. Or there are certain critical business applications that require access to the physical hardware, and they look for the physical hardware to boot up for the licensing purposes. That must go on a dedicated host. Dedicated instance would probably be a good case is I'm the US government, and I don't want the Chinese government systems on the same system or the Russian systems or the Greek systems or the Israeli systems on the same system, physical server as mine. That's when you use a dedicated instance. Good question, Igor. We will discuss NAT gateways and NAT instances, and we will cover that when we get to that content. What are some fundamental skills needed to have better understanding of this course? Network and data center. If you don't understand the network and data center, you will never understand the cloud. Please join us tomorrow on the completely free How to Get Your First Job webinar, and we will give you a 100% list of every single skill you need to know to be employable as a cloud architect. So let's get back to the content. If you can give me a hashtag, and the hashtag could be AWS Certified Solution Architect Associate. Okay, so let's get back to the content. Now, in AWS world, they tell you secure your virtual machine access with the security group. I'm going to tell you right now, that's great if you want to get hacked, but if it really matters, you're going to need to do much more. You're going to need host-based firewalls, host-based IDS. You're going to have to be removing unnecessary packages from the operating system and closing unnecessary ports. But in AWS certification world, which is very artificial in nature and contains about 5% of the knowledge of what you need to know to build any good career, they say you can secure your EC2 instance by using a security group, which is basically like a host-based firewall, but that doesn't mean you shouldn't use your own host-based firewall too, and all high security environments do. So what's it look like? We're going to talk about the concept of a security group. We'll talk about it much, much more when we get to the security section, but I just want to briefly touch on it now. When you set up your virtual machines, and if you download our free labs, which is, we gave you the link earlier in the video, you'll be setting up security groups. And basically what it is, it's a pre-firewall before your traffic gets inside of your virtual machines. Keep that in the back of your mind. And we'll discuss much, much, much more in much, much, much more depth, bear with me, when we actually get to the security section. So how do you give an IP address to a system? Well, when you set up your VPC, and we'll talk about that much more later, and you're setting up your virtual private data center, because that's what your VPC is. They call it virtual private cloud, but it's a virtual private data center, not a virtual private network. What you're dealing with is you have to create your own IP address space inside a range. And inside of that, every single virtual machine that you have is going to be given an IP address on the subnet that you create. And it's going to receive that address via the dynamic host configuration protocol. Now, if it's inside of your VPC and it's internal, you're going to be using private IP address spaces. And if you need to connect it to the internet, you're going to need a global or a public IP address, which of course the world calls it a public IP address, and AWS marketing people named it an elastic IP address. I don't know where they come up with these marketing names. So keep that in the back of your mind. Now you can also get a IPv6 address. Now all IP6 addresses are public. We don't have any kind of RFC 1918 private IP addressing spaces like we normally would. Keep that in the back of your mind. They're automatically assigned an IPv6 address. If you don't need IPv6, shut it off. The more addresses you have, the more things that are open, the more the world can hack you. So only use what you need. Now, how do you manage these systems? Well, how would you manage any virtual machine? You can either secure shell into them or SSH, just like you would any other Linux machine or router or switch or firewall. Ooh. You could use the AWS Management Console, which is a web-based, browser-based way to do things. It is super easy. It's basically self-explanatory. Click, 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 and it's done. And if you don't know, you can just Google the instructions. Having said that, it is slow versus SSH, which is much faster if you know the commands. And great question there from George. Do I have anything against the marketing team? No, but there's millions and millions of people that are 100% confused by what something is because the marketing people made up funny names. If it's a Windows system, you can manage it via the remote desktop protocol, RDP. And you can do a lot of the management via the software development kit. And here's how you can really set these things up. The whole world uses Terraform. They're going to have one DevOps engineer deploy thousands of these at the same time in many cases, and they can all do it via infrastructure as code. So that's how you can set up these things and manage them. Now, we're also going to talk about Outpost. And what is Outpost? It's fairly new. It's a fully managed service that uses a virtual machine or an EC2 instance and something that's an AWS applied instance. It's a physical appliance that's shipped to the customer and plugged into the customer data center. Why? Because the latency of going to the cloud is high versus running a virtual machine in your data center is there. So you can order a server directly from AWS, stick it in your data center, and that's called an Outpost. I'm going to tell you right now, you can buy that server from Dell for far, 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 far less than it would ever cost you to rent it out from AWS, at least 400% less, but it's up to you and how you want to do it. 300-400% cheaper to buy your own server. But if you buy your own server, you're going to have some knowledge on how to set up the virtualization. If you buy this AWS Outpost, the cool thing is you can just click a few buttons on the AWS Management Console and set up your servers, and it's fully managed by AWS. You don't have to think about patching the hypervisor and things like that. So it's a convenience factor. In fact, when you go to a convenience store, like a 7-Eleven in the US or a Wawa in the US, you pay a lot more than you would in the supermarket, right? For convenience. That's what we're talking about here. They do all the work for you, they manage it, and because of that, you pay more. But you get great performance just like buying your own server. Okay, now we're going to get into databases. So to make sure I know you're here, give me a hashtag that says databases. I see a hashtag that says databases. Give me a hashtag that says databases. We don't use acronyms as architects. Spell it out, databases. Your CEO doesn't know what you mean in an acronym. Your hiring manager doesn't know what you mean. And the reason we never use acronyms in technology, and some people do, but you should never, is they all can mean 10 different things. Somebody says VM, I don't know if it's a voicemail, vulnerability management, or a virtual machine. And that's the point. There's millions of things that all mean the same thing. So communication, lack of clarity causes errors. And I want you to have a great career and avoid acronyms whenever possible. So we're going to talk about databases. Even DB, I think of it means dumbbell. So keep that in the back of your mind. That's why we never use acronyms, because they all mean different things to different people. So what is a database? A database is an application that enables us to store large amounts of information. Large amounts. It facilitates the sorting, calculating, reporting, and information sharing. And it is a critical component to modern applications. Now, when we talk about these databases, I'm going to cover all of them. I'm going to tell you which ones you should probably never use in real life. Why? Because they will make multi-cloud impossible. And remember, 98% of organizations use multi-cloud. So I will cover all so you can pass the AWS exam. And then I'm going to tell you, don't use this when it comes to things like DynamoDB and Amazon Aurora and a few other ones. But we're going to cover them all. And then I'll tell you why you should or shouldn't use certain ones. Now, when we're dealing with databases, for the most part, we're dealing with the same ones that exist everywhere. We've got relational databases like Oracle. We've got NoSQL databases like MongoDB or Apache Cassandra. We've got data warehouses, which are things like Postgres. We'll talk a little bit about creating data lakes. I'll show you the AWS way, and if we have time, I'll show you the real way. But we're going to first talk about relational databases. And this is the most common database that we deal with in business. And it provides information and data that's related to each other. Cindy the cat, science diet chicken. So Cindy the cat goes and buys science diet chicken, and it got that in the database. Mike buys 500 pounds of Cindy the cat of science diet chicken because it's 30% off. Okay, great. So that's what we're really talking about. For my team, lots of people are having a hard time finding the webinar tomorrow. Please pop that in there so people can reach it. And we have a great cat, Cindy, by the way. Hopefully she'll pop in. So the reason organizations use relational databases is to find information that's related to each other. 20% off yields this much in sales. 30% off yields this much in sales, and enables the business to make better business decisions, finding information that's related to each other. Because remember, no business buys technology because it's cool. They buy it to improve their business. So with the relational database, we've got a lot of structure. Basically, we have a row and we have columns, kind of like an Excel spreadsheet. Exactly that way. Now, when you're dealing with relational databases, they're what's called atomic. And what does that mean? They use this thing called an acid model. You could find a certification question on this, but you should know this. Transactions are all or nothing, meaning Cindy the cat's order got placed or didn't get placed. And that's it. They are consistent. The second I purchase Cindy's cat food, the database knows it, and all the read replicas, etc., all know about it at the same time. It's consistent. It's isolated. I buy fresh shrimp for Cindy. That's on a different entry than when I bought her science diet. And Cindy gets her shrimp every single day, believe me. And when she's not getting that, she's getting tuna and scallops every day. She's a very happy cat. And they're durable, meaning once an order goes into that database or a transaction goes to that database, it is not lost. So they follow the atomic, consistent, isolated, and durable model, otherwise known as ACID. So when you look at a database, the key is relational database show the relationships between variables. That's why businesses are using it. You've got your order ID, your customer ID, your amount, your email address, the person's name, everything that's related to each other. So transactions, things like that. You purchase something, and it's pretty great. So that now you know what we're talking about. Information that is related to each other. Now, when you deal with Amazon, you got two options for your databases. You really want full control, don't use any of their database, anything. Set up a virtual machine and install the database yourself, just like you did everywhere. If you don't feel like setting it up, you can take the easy way out and you can set these things up. Now, the relational databases available on Amazon are Amazon Aurora, MariaDB, Microsoft SQL Server, MySQL, Oracle DB, and Postgres, which is typically used as a data warehouse. We're going to begin with Amazon Aurora, and I'm going to tell you right now, you probably should never touch this, but it's going to be on your certification exam. If you use a proprietary database, when you use 3 clouds, you're going to have trouble, and 98% of customers use more than 1 cloud, for good reasons. Single cloud is a single point of failure, no matter how many regions and availability zones you use. Because a control plane failure, a network failure, or a hacking event will take down an entire cloud. Heck, we've seen AWS go down globally for 7 hours, which they called power failure, although I've never seen a data center power failure in 25 years. So Amazon Aurora is a proprietary, meaning it's going to cause problems if you deal with anybody else. Warning, 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 warning. Is a fully managed relational database. They say it's MySQL and Postgres compatible, which means it is, but try and get your information in and out, and you're going to be using tools. Now, what is good about this Amazon Aurora database is it gives you some of the enterprise-grade features that you would get in an Oracle-type database or a paid database, and it's relatively inexpensive. So there is that. And if you only had a small business that you never thought was going to grow, and it could tolerate an hour a day of downtime, this might be fine. But I don't know any business like that. At least the kinds I work with. And Amazon will tell you it's 5 times faster than standard MySQL. Heck, yeah, MySQL is kind of a really slow database. And 3 times faster than Postgres. Now, it's kind of a SaaS application or a software as a service application, meaning it's serverless and there's no servers for you to manage. Now, when you don't have any servers to manage, it's like going to McDonald's and getting a hamburger. You've got no control over it because it's managed by somebody else. Versus having your grandmother, who's a chef, make you the perfect hamburger. Kind of keep it that way. So now we're going to get into MySQL. It is an extremely common relational database. It's open source. It's been around for decades. Oracle owns it now, even though it's free. And it's used in a wide variety of applications. You've probably heard of the LAMP stack, Linux, Apache, MySQL, PHP. That's what we're really talking about. Now we can talk about Postgres. Postgres is an exceptional data warehouse. It's also considered a relational database. Very enhanced feature set, huge functionality improvements over MySQL. And that's one you can either use their setup, which is basically going to be on an EC2 instance, otherwise known as a virtual machine. And guess what? It's going to be using block storage. Or you can just set it up yourself, whatever you want. MariaDB. Now, this is another really exceptional relational database. It's open source, which means it's free. And it works everywhere. It's created by the people that created MySQL, but it's got a lot more additional features and functionality. Now we're going to get into a paid database, Microsoft SQL. A lot of this stuff out there. Amazon supports MySQL Server 2008, 2012, 2014. And this basically allows organizations that have Windows workloads that are dependent upon Microsoft SQL Server to be used. Now, Microsoft has very different clustering and failover options than most databases. And there are 4 versions of it: Express, Web, Enterprise, and Standard. Look, you can use any of these. And if you needed something different, you can always build the virtual machine and install it. Now we're going to go to the king of all relational databases, the Oracle database. If it matters in business, for the most part, they're using the Oracle database. It is one of the most popular relational databases in the world. It has, for the most part, one of the most extensive feature sets and functionalities. And it's developed, licensed, and managed by Oracle. AWS Relational Database Service supports Standard 1, Enterprise, and standard. Each of these versions has different performance, flexibility, and scalability options. There's 2 versions of licensing supported by AWS for the Oracle database. License included, and basically, realistically speaking, in this version, the database is licensed to AWS, and you're using their license. And you can use Standard Edition 1 or Standard Edition 2, or you can bring your own license to Microsoft. And this is assuming you have a license, you bought it, bring your own license to AWS, you brought it, and then you're going to host your database on AWS. Now you got lots more licensing flexibility, Standard, Enterprise, Standard Edition 1, Standard Edition 2. Now, in a bit, we're going to talk about tuning the performance of these things with read replicas, caching, and queuing. We're going to have lots of fun with that. But before we do, we talked about the relational databases that are supported. Now we're going to talk about NoSQL databases. Now, a NoSQL database is not new. They're from the 1970s, if I remember correctly, from IBM. And what a NoSQL database means, not only SQL. So we talked about a relational database having very strict columns and rows with data that's related to each other. Great for transactions. But what if you need a little more flexibility? See, anytime you've got tight constraints, this must be this, you start limiting scalability. So a NoSQL database was designed to give you a lot of flexibility in the way you store your information. You can store structured data like transactions, unstructured data like where you stopped in a Netflix movie. Oh, by the way, there's this new show called Night Agent. I was watching it the other day on Netflix. And it's pretty interesting. Every time you push pause and you come back to it hours later, it takes you to the same spot. Because they're using a NoSQL database. I believe it's Apache Cassandra these days. Meaning I'm 99% sure they're using Apache Cassandra to store your place. And that way it stores your information and you can pull it. Can't do that kind of thing with a relational database. Video game people that actually play a game, right? And they go back to the same game, they stop it, that they're using a NoSQL database because it's very flexible. And basically what happens is we've got these pairs, and we've got IDs and values, and that's how the information is retrieved. So AWS has their own managed relational database called DynamoDB. Something that I will never use, ever, ever, ever. Not because it's a bad database. It's an exceptionally good database. But you use DynamoDB, and guess what? Now you got a problem with Google, Oracle, Azure, Nutanix, and OpenStack. I can't have that for my business. I can't architect single points of failure. So this is something that's right for the trash can. AWS invented it. Now you use this, you're stuck, you're handicapped to AWS, and when they raise your rates, you're out of trouble. When they have an outage, you're done, and there's nothing you can do about it. So DynamoDB, trash can. Go back to something like MongoDB or Apache Cassandra. But you got to do this. It's not that it's a bad database. It's that I don't believe in architecting single points of failure into environments. So we will talk about DynamoDB because they're going to have lots of questions of it on your exam. Because they want to put you in an environment, all cloud providers or all vendors want to put you in an environment where you're exclusive to their stuff. And it gets really, really hard to leave. Like the Hotel California song, you can check out anytime you want. You can check in anytime you want, but you can never leave. I'm not going to have a career as a rock star, which that's another story. But so let's talk about it. AWS has a fully managed serverless database called DynamoDB. They say it's highly available, and as long as AWS works, it's going to work for you. It's serverless, which means there's no management of the servers. They're still servers, but they manage the operating system, your storage, the security of it, and hopefully they do a good job of it. And it stores your information on SSD storage for better performance. Now, the good news is it's got low millisecond latency, and it encrypts all your data by default, and it can be backed up with little or no performance, and it can be set up for global cross-region replication. Now, when I say that it's proprietary, that doesn't mean you couldn't convert your information and move to a second cloud. The problem is going to be when you want to synchronize your data between the Azure cloud and AWS cloud, you can't do it with DynamoDB. You also can't do it with Google Cloud Bigtable. And you can't do it with any of the proprietary databases. So you really need to understand that. So it can be set up for cross-region replication. Again, great, but if the cloud goes down, doesn't matter how many regions you're in. Now, because we're dealing with a NoSQL database, we're dealing with name-value pairs. And we've got what's called the primary index, which is basically your primary setup, but we can also set up secondary indexes, which allows applications to have access to different query patterns. DynamoDB secondary indexes can be something called global or local. Local indexes will have the same partition key as the base table. Global indexes can span across all database partitions. Now, there's going to be some limitations on size. A key value can't go above 10 gigabyte, but that's pretty big. And to increase scalability, DynamoDB is eventually consistent. What does that mean? It means that if I write information to the database, other parts of it from a second or two may not have access to the most up-to-date information. So does it matter? It depends. If it's a bank and I purchase $1 million of Cisco stock, and then want to sell $1 million for an eighth of a dollar more a second later, well, yeah, it better be immediately consistent, and this isn't going to work. But if it's something where you stopped in a Netflix video, does it matter if it's inconsistent for a period of 5 seconds? Of course it doesn't. So as you increase the scalability, you become eventually consistent versus instantly consistent. Now, of course, you could configure DynamoDB, should you be using this thing, to be strongly consistent, meaning instantly consistent, but that'll knock down your scalability. So everything with architecture is going to be a choice. Everything you do, if one thing affects something else. It's like throwing a pebble in a river or a lake, and you notice that it reverberates, and you see these things. That's why architecture and engineering are different. Engineering is focused on the tech. Architecture is focused on the big picture, because you got to be able to see everything that's going on. Keep that in the back of your mind. Now, with DynamoDB, you need to understand that you provision the capacity. You have to tell it how much you're going to need before you use it. You provision your read capacity and your write capacity ahead of time. And that way there's sufficient capacity for your needs. Now, this is really scary. You could set up DynamoDB for auto-scaling. Now, normally, auto-scaling adds capacity when you need it and removes capacity. Pretty cool, exciting, and that's the whole reason we're on the cloud. If it wasn't for auto-scaling, for the most part, the cloud would be more expensive and lower performance than the data center. But auto-scaling is really exciting. Now, DynamoDB auto-scaling is about the worst I've ever seen in my entire life. It scales up and doesn't scale back down. Why is this so bad? Let's say you had a period of 5 minutes where you needed to scale up, or maybe 30 or 40 minutes, and then your capacity was reduced for the rest of the year. That means what's going to happen is you're going to pay for the rest of the year for the peak performance that you had 5 minutes, which is something you don't ever want to do. So with DynamoDB, which I don't recommend you use because it's proprietary and it's going to lock you into a single cloud, which no customer wants. If you're going to use it, provision it ahead of time and don't allow auto-scaling to work, because it scales up and not down. Now, in order to make this look more attractive to people, they offered a new option, because people are not going to use something that doesn't work in multi-cloud. When 98% of organizations are using multi-cloud, AWS had to do something. They created an ability to create an infrequent access table, which gives you lower cost for infrequent data. And you can save up to, but there's a 25% fee to save and retrieve your data. And DynamoDB is always priced upon throughput. On-demand capacity, as we're talking about, is going to be available for a higher cost than fixed capacity. So what are some use cases that AWS would tell you for DynamoDB? Or it's the same as any other NoSQL database. When near unlimited scalability is required, when lower latency is required, because these things scale very well and latencies are low, all NoSQL databases. When you got to store a large amount of stuff, Internet of Things devices that are all over the world. And I think Eva Doik is here. She wrote a beautiful article, and she wrote it on edge computing, where you got all these Internet of Things devices coming in. That's what we're talking about. DynamoDB or any NoSQL database would be great for that. Game player state, where somebody's in a video game, leaderboards, that kind of stuff. Netflix movies. Well, Netflix uses Apache Cassandra these days, but keep that in the back of your mind. Huge number of financial transactions, e-commerce, shopping cart inventory and tracking. That's what we're going to use these things. Now we're going to get into a data warehousing. Now, for everybody in the entire world, that means Postgres. Keep that in the back of your mind. AWS will also have their own one, which again, I'm going to strongly recommend you don't use because it's proprietary. So we'll talk about data warehousing. Data warehousing is where you store large amounts of data. Why do you store humongous amounts of data? Same reason we do any piece of technology, to improve business performance. Keep that in the back of your mind. So what we take all this information and, for example, we stick it in a relational database, and then we can run a business intelligence tool. And the business intelligence tool can help us visualize the data. We can then take this data out and we can prep it, load it, create our data lakes, things like that. Now, there is that. So again, I'm going to show you the AWS proprietary way to do this, which is not what I'm recommending. Here you take data, you could store it, for example, in an object storage bucket, which again, we're going to use that on all clouds. We love this so far. Then you're going to have to map and reduce and normalize your data. The rest of the world uses a Python Spark script. I'm going to recommend you create a Python Spark script, or at least your database people do. Why? Because it can take the Python Spark script and use the same script on the Azure cloud and the Google cloud at the same time. And then you're going to stick your information into your data warehouse, which I recommend Postgres, not this Amazon Redshift. And then from there, you can look at your data with a visualization tool like Microsoft Power BI, Amazon QuickSight, what have you. So now we're going to talk about Redshift, which again is something I don't recommend you ever use. I recommend you use Postgres or another data warehouse, but I would never use a proprietary anything because it's going to hurt you when it comes to multi-cloud. So Amazon Redshift is an AWS proprietary managed data warehouse solution. It helps you just like any other data warehouse would work. And it's going to help you find actionable information. You can use it for business analytics. And you can use Redshift Spectrum to provide real-time insights into your business. We'll talk a little bit more about this proprietary database, data warehousing database. AWS would tell you it's fast, powerful, and fully managed. It can do petabyte scale warehousing, as can any Postgres. It's based upon Postgres, which is good because you can do SQL queries. And it works with applications, but just use Postgres and how do you deal with this? And then you can use the same thing on multiple clouds. Now, when you're dealing with Amazon Redshift, the primary architecture is built upon clusters of computing nodes. You're going to have a primary node that's going to be considered a leader node, and the compute nodes are going to support the leader node. And your queries are always going to be directed to the leader node. What we're going to do, because I know I've been going long, is I'm going to briefly mention data lakes in the context of what AWS would consider for your exam, which is typically different than what we do in real life. And then we're going to open up some questions before we get into storage and things like that. What is a data lake? A data lake is a repository where you store structured and unstructured data. It's typically in object storage. The reason organizations create data lakes is because we want to create a location to process a large amount of data, and it doesn't require you to structure the data as you would in a database. For one of the people with the blue wrenches, can you find the data lake presentation where we had Praveen, a really wonderful big data architect and a cloud architect, speak for about 2 hours on how to create a data lake and what a data lake is, and pop that into the chat box for everybody that's here, because we don't have the multiple hours to cover that. And I wish I was, but I'm not Praveen. Praveen knows an incredible amount of big data architectures. I am an enterprise architect, a cloud architect, and a network architect. And I'd rather you hear from someone with 20 years of big data experience on this than me, because you get better information. So that's why we create a data lake. We store large amounts of information. It's cataloged information. And that way you can query data and you can look for it. This is what the AWS wants you to see as the data lake. You're going to have your data sources, which is going to typically be a NoSQL database, your data warehouse, and your relational databases. You're going to typically have someone write a Python Spark script for your data transformation. And then you'll create your data lake. And there's several steps in the process of creating the data lake, of normalizing data, catalyzing data, but that's realistically what we're talking about. Okay, let's go to some questions. And then, because I know I've been speaking for approximately 30 minutes, and then we'll get back to the content. We'll have all kinds of fun. At least I'm having fun. Are you guys having fun? How to make a relational database highly available? Well, Abhishek, 1 is none, 2 is 1, and 3 is greater than 2. So we're going to talk about that when we talk about database performance tuning. But never have one. And never have a single database. And realistically speaking, if it really needs to be high available, put it in multiple clouds, not a single cloud. Great question. We'll get to more of that later. What DB options do you have to save MongoDB data to AWS? Well, if I was you, I would stick a MongoDB servers inside of AWS, and that's all you'd have to do. Read replica. Does it like taking backup? Read replicas are for something else, but it can partially help you with backup. But it's really designed for something else. We'll talk about that more when we talk about high availability. How do you ensure high availability and data durability for databases in AWS? Don't just stick them in AWS. Look, we've seen global outages with AWS. We've seen global outages with all the cloud providers. If you use a single cloud provider, I promise you, you will see an outage. And it doesn't matter how many regions you use. All tech fails, all service provider fails. In network architecture and enterprise architecture, we've been taught for the last 25 years, never put all your eggs in one basket. In finance, they say diversify your portfolio. We always add redundancy. No matter how many availability zones and regions you use in a single cloud, you are architecting a single point of failure if you stick it in one cloud. Take your database and stick it in multiple clouds. Now you've got a truly high availability database. Can I explain the advantages of Redshift? None. Don't use it. Instead, use Postgres. Anytime you use proprietary, for every one benefit you gain a whole lot of problems long term. I wouldn't recommend you use it. Can you convert to DynamoDB to another type? Yes, you can. But that means you can't use multiple clouds at the same time. So you could be with AWS. AWS has another 7-hour global outage, and they talk about something like a power failure. You don't believe it's a power failure. Now you want to go to Azure, or they raise your rates and you want to go to Azure, and now you got a problem. But Sarah, if you want to run Azure and AWS at the same time for high availability purposes, you can't be converting data back and forth to each other. You need to use the same database. Trash DynamoDB and use MongoDB or Apache Cassandra across your clouds, and you'll never have a problem. So you have to match storage sizing with databases? Yes, absolutely. That's the way we've done it for the last 20 years. Does AWS support Cassandra? Yes, they do. Do they do it without having to provision many underlying infrastructures? Yes, they do. They have a managed key spaces. Mark, I don't recommend using serverless. I recommend your architects design something and your engineers build it whenever possible. You have no control when somebody else provisions and manages it. No control whatsoever. You go to McDonald's and they say, would you like fries with that? And your hamburger comes out consistently, identically, in a good enough manner every single time. I haven't been to a McDonald's in 10 years, but there is that. If I go to Morton's and ask them to make me a hamburger, I can select prime beef, prime rib, filet mignon, New York strip to grind that hamburger into. And they can basically make it medium rare, medium well, or whatever I want. When you use managed services, you don't get any of that. It's the do you want fries with that? Now, is managed services good? Well, they're often a little easier to manage, but there's a trade-off. You're going to trade off something. Performance, tunability. So the customers that I work with don't use as many managed services. They use their own. Remember, if you use managed services, it's a little cheaper and it's a little easier to manage. You don't need as many expensive people working on it, but you give up control. And is that a good thing? Sometimes yes, sometimes no. If you have a team of inept people and you don't want to train them, great. Use a managed service. If you have good people and you're not worried about their training, you can do many more things. So what are the business requirements will always determine what you should use. Can I explain the Redshift primary node? Absolutely. So basically speaking, Redshift is managed around clusters of computing nodes. You've got the primary node, which is called the leader node, and every other node is called a compute node and supports the leader node. But all the SQL queries go straight to the leader node. Good question. How do you normalize data in the data warehouse? Well, once it's in the data warehouse, it's normalized. Typically speaking, when you go from one database to another database, you're going to have to map and reduce it. Now, AWS, of course, has its own proprietary Elastic MapReduce, but, and that's real, and we'll talk about what that's based on. What organizations really do is they write a Python Spark script. PySpark is really created for normalizing data. And you can set that same PySpark script up for, at least your data people will do it, and we architects won't touch it, for example. And they'll set out that same script, and you can run that same script in Azure and Google, or Nutanix, or OpenStack. And that's why, for us, we like to use standards, and we try to avoid proprietary things whenever possible. How do you maintain a database sync between multi-cloud? The same way you synchronize between multi-region. You've got IP connectivity. That's it. As long as the network works, all this stuff works. Is it possible to run multiple databases in a database instance? I don't know what you mean by that. You can partition a database, which is sort of like that, but not exactly. But I'm not completely sure I understand what you mean. Can you virtualize the entire data center? Yep, that's what a cloud is. Every data center has been virtualized for the last 20 years for the most part. If you get, and the second half of that was, if you virtualize a data center and it goes down, you're done. And if you're done. And if you've got 10 data centers connected by the same network, or 100 data centers connected by the same network, and the network goes down, guess what? What you're dealing with is all of it goes down, which is why you should never use a single cloud. Same problem. DynamoDB is not scaled down. It's effectively the maximum number of increases in the data 27. I don't know what you're referring to. According to the AWS documentation, it scales up in terms of the throughput and capacity, but it doesn't scale back down. Is there a difference between managed and fully managed? Fully managed means you've got no control whatsoever. Managed generally means you have limited control. Hypervisors not only split the physical machine into multiple logical machines, they do that, but they also combine multiple physical machines into one logical machine. Is this correct? Generally speaking, no. They combine multiple physical machines into a compute pool that you can pull from, just like a cloud provider would. Good question. Good question. So before we go back to the content, let's talk about, let me give you a hashtag, because I want to know you're awake and learning it. Why don't we change why don't we give the next hashtag to hashtag free AWS course? That way I know you're awake, alert, and oriented. And while I'm waiting for that, if you get a VMware vSphere, one of these environments, it takes all your servers and adds it to a pool. Tech Electric, if you get a Nutanix cloud or an OpenStack cloud, it's going to do the same thing and add it to a physical pool. That's what cloud software does. It's different than a hypervisor. It's the control plane that manages it. AWS has the control plane. Nutanix has the control plane. Every cloud has a control plane. And if that control plane goes down, you lose everything. And yes, a shout out to all the people behind the scenes, whether it be my Chief Operating Officer, Christopher Johnson, my Chief Marketing Officer, Alonzo, whether it be Leo, who's back there, whether it be Chow, who's back there, whether it be Tyrone or Eddie or Anselm. There's lots of people here. There's some volunteers like Eva Doikio, who we were always thrilled to have here. Thank you all for all your participation. And I know I'm missing people. AJ is one of them, really great guy who's also helping. So let's talk a little bit about where you're going to store your data. In a database, right? Realistically speaking, you're going to have three options. Option one is going to be you put it on provision IOPS, which is AWS fastest, which is still very slow storage, as I showed you compared to other storages yesterday. Now, your next option is general purpose SSD, which is, again, much slower than that. And your last option is magnetic storage. So realistically speaking, if it matters, you're going to be provision IOPS. You may get away with general purpose SSD on really small environments, but you're probably not going to use magnetic storage for any kind of database. The latency will be too high. There's one more database I want to talk about before we get on onto this, and it's the Quantum Ledger database. Amazon has a Quantum Ledger database that is fully managed and serverless, that automatically scales with application. Being serverless, it eliminates the need or worry to process server capacity. It uses tables and indexes to query stored historical data. And unlike traditional databases, it's with non-immutable record-keeping audit logs like relational databases. AWS Quantum Ledger does not permit add, update, or delete operations. So if you've got something that's a database in a highly regulated industry, you can use the Quantum Ledger database. But again, there's other industry databases that do this that are not proprietary. So we recommend those. Now, let's talk about database optimization. And we're going to have Amazon database optimizations, which is what we're going to talk about. These are the same things you would do with any database, by the way. We'll talk about backups, automated backups, database snapshots, and encryption. You know, and anytime we're going to be dealing with optimizing our databases, we're going to be talking about scalability. We'll talk about read replicas. We'll talk about caching, queuing, multi-AZ, and realistically speaking, think multi-cloud, which is not part of any AWS certification but it's part of reality. Backup. If it matters, you got to back it up, right? Now, if you use one of the AWS managed database services, like MySQL or Oracle, they do some really good things for you. Now, I like full control, but I have no problem using the Oracle managed database service on AWS. What they do is they back up your data in a very great way. The entire database is backed up onto an image. And you can retain this backup from 1 day to 35 days. And the backups happen at the same time each day for the most part, defined window, which is really great. And during the backup, you got to know, because it's pulling data off of the drive, the database may be temporarily unavailable. And when you're pulling the data off of the drive to back it up, the performance of the database, if it's not available, may be severely degraded. Kind of keep this in the back. So when it gets backed up, it's going to be in the form of a DB snapshot. Now, you can also make your own snapshots. You know me, I love control. And DB snapshots are a point-in-time copy of the entire storage volume. Like that old-fashioned ghost image, that's 100%. Got the operating system, all the patches you put in there, all the dependencies in there, applications, and of course, all your data. So you can back up the whole thing, which is really cool. And you can relaunch that thing instantly should you have a problem. Another region, another availability zone, etc. And when you make a DB snapshot, it's available until you delete it. So what does it really look like? You've got the relational database, and you can create a snapshot of it. That's it. Now, when you restore a database from a snapshot, you're going to get an identical new virtual machine with one exception. it's going to come up with a new IP address, which means the old DNS name that you have is no longer going to work. It's going to have a new DNS address too. So you may have to update your DNS records if your systems use DNS to point to the new system. And people typically use DNS. And if you use the IP address of the system by comparison, which we don't recommend for lots of reasons, then you're going to have to update the IP address mapping in your application servers, which are going to the database. And when you restore it, you take your snapshot image, and poof, you've got a new database with a new IP address, just like I described, and a new DNS address. Now, if you're going to store your data on a database or any hard drive, and the hard drive's lost, stolen, or your identity is compromised, guess what? People can read your information. Do you want that? No. So Amazon supports encryption at rest for all your database. So what does this really mean in all practical terms? It means all the data stored on your server is encrypted. Effectively, what's going on is the EBS volume or the block storage or the virtual hard drive is encrypted. This is enabled by enabling the key management service, which makes it real easy to control the keys. We talked about the key management service and a lot of these things yesterday. AWS also supports transparent data encryption. And transparent data encryption is typically used to be with Oracle and Microsoft SQL databases by default. And you can set up transparent data encryption with the cloud HSM module. It's like a hardware key encryption kind of manual. We'll talk more about that later. And transparent data encryption is really kind of cool. It encrypts the data on demand and decrypts the data on demand. So when you store the data with transparent data encryption, it is encrypted. When you pull the data, it is decrypted. And the cloud HSM is a hardware device for storage and management of your encryption keys. AWS also supports encryption in transit. What does this mean? It means that your data is encrypted on the way to the database to be stored. And how does this work? Well, basically it uses the TLS protocol and SSL certificates. And you use the certificate to basically assist with the authentication of the endpoints in your data. Basically in the same way when you go to a website and you see the little lock and it's using SSL-based encryption, that's really what we're talking about. Now, databases have become really mission critical applications. So how do we improve the scalability of these things? Well, the simplest method is to scale up, meaning we're in a server that's got 8 cores and 32 gigs of RAM, and we bump it up to a 64-core server with 1 terabyte of RAM, or a 192 core server with 6 terabytes of RAM, and we pick it. But at some point, I promise you, you're going to run out of capacity, no matter what you do. You'll run out. So when you run out of capacity, you're going to have to add capacity. Now, with some databases, like Apache Cassandra, for example, you can write to all databases at the same time. I'm 90% sure Oracle database allows that as well. But most do not. So we'll talk about how we're going to deal with this, because it's not like you can just auto-scale a database the same way you can auto-scale a web server. Lots of trickiness here, lots of it. And at some point, you're going to have to start getting creative. Now, with no SQL databases, this is simple. Apache Cassandra, you just add servers and it writes to them all at the same time. With DynamoDB, which again, we're not recommending, you can basically partition the database and it chops or shards the database into partitions, and the application will have the intelligence to route your traffic to the correct shard. Now, with relational databases, it gets a little more complicated. What we do is we add read replicas. Okay, what's a read replica? A read replica is a read-only copy of the data. Now, except for MariaDB as well. Now, read only. So what does this really mean? Right now, I'll give you an example. There's all these blue wrenches in this YouTube chat box. For today, I am the primary master database, meaning I'm out here providing the information. And many people are asking questions of things that I covered, and they need a little clarification. And there you see the little blue wrenches, whether it be my Chief Operating Officer, Chris, who's over in Tampa, Florida, or Oforka, who's over there in Cameroon, who's answering questions, or Chow, who's over in Dallas, Texas, little super Chow over there, and she's answering questions, or Alonzo, who's over there in Katy, Texas, answering questions, or Eddie over in Bamenda, Cameroon, that's answering questions. They're kind of like read replicas. They basically enable me to focus on what I'm teaching, and they help answer things. Kind of keep that in the back of your mind. So the way we use read replicas is the database has something called write capacity and read capacity, and a primary database does it both. A read replica is a read-only copy of the instance. And what happens if we take the read load off of the primary server and we push it onto some other servers, the primary server can focus only on writing, and the read replicas can handle the read traffic. And remember, if you've got a server that's got to read and write, and you can remove all the read and it only has to write, it can scale further. And why are we doing this? Because as I mentioned previously, there's only going to be a certain amount of server cores and DRAM and disk performance you're going to be able to get. So we're going to have to get past this. And that's how we're going to do it. It's going to reduce the load. So what does it look like? Architecturally, here's what it looks like. Basic 3-tier application. We've got our web servers, which can auto-scale. We've got our app servers, which can auto-scale. We've got our main or master database. And we've got the read databases. And what happens is you'll point your questions to the read database, and that'll free up the write database to do more. So when you use read replicas, when there's read activity. If it's all write activity, read replicas aren't going to do anything. When query traffic, meaning people are trying to read, is slowing things down, you need a read replica. If you've got 4 times the read capacity than the write capacity, add 4 read replicas, because it's adding extra capacity. Now, while we're at it, I want to make it clear, read replicas are used for performance. They do not aid in availability or disaster recovery for the most part. Now, the next thing we're going to talk about is database caching. What is caching? Caching is a service to take frequently accessed information and put it in memory. Caching works by taking a request and temporarily storing the results of the request. Now, why would we use caching? Let's say, and we're going to use a NoSQL database with caching right now. And the reason we're going to use a NoSQL database is Taylor Swift gets a brand new cat. And she posts to Instagram, Facebook, Twitter, TikTok, and LinkedIn all the new photo of her cat. And somebody's pulling the information out. Pretend the cat is stored in the database, the cat photo. Now, the read replica can answer the cat's question. And then the cache can keep re-answering it, offloading the read replicas. So the read replicas offload the write, or the primary database, and the caching can offload the read replica. Now, if all the information, if one thing's for Taylor Swift's cat, another thing's for Katy Perry's cat, another thing is for Chris's cool cat, Sunny, and the next request is for my super awesome princess cat, Cindy. By the way, I bought her for my wife and realized the cat's the second love of my life. I love this little cat. But, that's neither here nor there. Then the caching's not going to help. In fact, if you add caching in an environment where all the requests are different, it will slow things down. Caching is used from frequently accessed information. Now, typically speaking, organizations have been using caches forever. There's 2 caches that are typically used in business. For the most part, businesses use Redis caches, and they also can use Memcached. Now, of course, in the cloud, you could set up your own servers with your own DRAM and set up your own Redis cache or your own Memcached cache. Or you can use the fully managed AWS cache. There's no reason not to use these things. It's pretty simple to set up. And you can basically use a pre-made Redis cache. Now, people use Redis because it's got the most robust feature set of all caches. It's typically used. And you can manage, Redis workloads to Elasticache, or you could set up your own cache, which in certain cases makes sense. It's based on the business requirements. Now, if you need something simple, you can use Elasticache for Memcached. It's simplicity. And Elasticache is compatible for Memcached is also compatible with Memcached. So there's, these caches aren't that different from each other, but if it matters, you're going to be using Redis. I told you how caching sort of helps. I'll show it to you visually. If the requests keep coming in for information that's on the database, the cache can store that in memory and provide the answers so that you don't have to do so accordingly. Now let's talk about database queuing. And if you want, I'll actually architect these things together for you to try and put it into context for you. What is queuing? For the Americans, it's a complicated concept. For the English or anybody that follows, colonial English language, it's simple because caching means put everything in a line. You go to a plane in the UK and they say, please form a queue. So queuing is really a means to schedule the delivery of your data. It's used in lots of applications. And why we're using caching, test question here for the AWS Solution Architect Associate. Why do you use a cache? It's to decouple the traffic destined from the database and your application service. It's used for application decoupling. You may see a test question on that. You most likely will. Caching is used to decouple it. Here's the way caching really works. Caching is used for, you've got a sender who's sending a message. They stick the message in the cache. When the receiver is ready to receive the message, guess what happens? It gets pulled from the cache. I'm sorry, the queue. I keep calling it a cache. It's a queue. And then it's removed from the queue. So I want you to think about this. If I'm sending messages as fast as I can and the receiver's not ready, they're going to be lost and dropped. But in this particular environment, I can dump all those messages into the queue. And by dumping it into the queue, it's a holding pattern. So I got 1 million messages, I stick them in the queue, and when the system's ready, it will drain them. So caching promotes scalability. It enables you to reduce CPU sizing, and I'll show you why. And generally speaking, the queuing lowers your cost. I'm sorry, I keep calling it caching. I'm referring to queuing. Now, most businesses use Apache Kafka as a queue. And you can set up a virtual machine and use Apache Kafka on all your clouds at the same time and use your same beautiful queue, Apache Kafka, as a queuing system. Or you could use the proprietary, which I don't recommend, AWS SQS or Simple Queue Service. And by doing so, it's a pre-managed queue for you. But if you're going to use 3 clouds, you're going to have 3 different proprietary queuing systems. Might not be the simplest, most elegant thing, but if you use Apache Kafka, which works on all clouds and all data centers at the same time, it's going to simplify your thing. So again, SQS is another service that I wouldn't be architecting into anything unless it didn't matter. Because everything I do is multi-cloud, just like 98% of customers. So when it comes down to it, there's 2 options. There's a standard version, which is a simple queue. Basically, messages come in and out as fast as they can. There's no guarantee of the order of the messages. And if you need to guarantee the message delivery, what you could choose to do is you could set up a FIFO queue or a first in and first out queue. Message 1 goes, then message 2 goes, then message 3, but it's going to slow it down. Why? Because what if message 1 was 1,500 bytes? Message 2 was 1,500 bytes, but message 3, 4, and 5 were 64 bytes each. The 3, 4, and 5 is going to get there most likely before message 2. And when you set up first in and first out, you're going to slow the system down. But it's up to you. Some application and business requirements require you to do so. So the reason we're using these queuing systems are as follows. Let's pretend we're looking at the CPU performance of a database. In your typical three-tier environment, I use proprietary technologies here just because it's an AWS class when I do these pictures. You got your web server coming in. You got your app server coming in. It uses this proprietary queue, and then it gets stuck into the AWS proprietary DynamoDB. Now, if this was a regular database, what you're going to see is the CPU is going to have periods of nothing. It's going to spike. It's going to go down. The CPU is going to spike, and it's going to go to nothing. But by using a queuing system, we can smooth out. And by using queuing, effectively what we're doing is realistically speaking, we're smoothing it out. So that way we pop stuff in the queue and we take it out on a consistent basis. It's kind of like driving at 40 miles an hour in your car versus at 2 miles an hour, 100 miles an hour, 2 miles an hour, 100 miles an hour. Which do you think is going to be more efficient on fuel and your car's longevity? That's why we use the queuing. So queuing helps remove write contention. It keeps messages from being lost. And what else also cool is you can use the depth of the messages in the queue to trigger out auto scaling of different servers, which we love. So when should you use a queue? When you want to increase the scalability because there's a lot of write requests. So caching reduces read load. Read replicas take the read load off of the primary database server. Queuing reduces the write load. And it keeps you from losing critical messages. So let me whiteboard this out so you can kind of see how you would scale the database. So wake up, everybody. Wake up, wake up, wake up. This is bonus content. This is actual architecture information, which goes way above anything that's covered in the course. So it's bonus, bonus, bonus. So make sure you're awake. So what does this really look like? If you're, let's say here is a web server or group of servers. I think in this direction. Some people think in the other direction. Both work. It depends on which country you're from. Let's say you got your web servers, then you got your app servers. On the way into the database, we put a queue.
Hey, Mike, we don't see your screen.
Oh, well, thank you for that. So we set up a web server, an app server, and then we put a queue here. This could be SQS. It could be Apache Kafka. It really doesn't matter. We're going to use queue. By using the queue, we can increase the scalability on the way into the primary database. And I'm going to show this to make life simple. And this is going to reduce the write load. Because web messages come in from the web server, the app server, instead of all being thrown into the database and potentially lost, we're going to add a queue. Now, if we want to increase the capacity of these, now the primary database reads, writes, reads, writes. So if we want to offload all the read work from the database over here, we're gonna add some read replicas. So and now we're going to point all the traffic to the read replicas. Now the read replicas are doing the answers. But what if we want to reduce the load on the read replicas? Well, realistically speaking, we could stick a cache here. And the cache where I'm putting in here architecturally is debatable. I'm using it for simplicity and elegance to make it clear what we're using it for. The cache can reduce the load on the read replicas that are doing all the read work. So, that's why we're using this. The queue reduces the write load, and the cache and the read replicas reduce the read load on the system. Okay, I think now's a good natural time to pause and answer some questions because I want to make sure everybody has a great learning experience.
All right, give me a few seconds to find
Sure.
the questions.
Can you speak how this integrates to an instance? High levels feel like instance must speak us. I don't know what that means. It's missing, Clyde, I'd love to answer your question, but it's missing. Oh, it's missing the question. You say how this integrates, how what integrates. If you can help me, I'll be thrilled to answer it. You may have asked it at the time during the presentation, but I don't know what I was saying at the exact time. Chris, let's go to the next question, and I'm thrilled to answer that if Clyde provides the context. Any options to mitigate degraded performance during a backup? Nope. It's just part of the system the way AWS has designed it. Can you pull out your data of a proprietary system, Lady Godiva? Absolutely. How difficult is it? Well, anytime you put stuff into a proprietary system, you pull it out, there's going to be challenges, there's going to be cost, there's going to be development cost to kind of do these things. But yes, you can do it. Will information be lost in the process? Yes. Is it going to be a perfect migration? The answer is no. So it's best just to avoid proprietary in the first place. What's the difference between a web server and an app server? You go to www.gocloudcareers.com. You got a web server. Now, when you sign in as a student of our Cloud Architect Career Development, which teaches you how to be a real architect and gets you hired as an architect and changes your life forever and gives you a great salary, our content is housed in the application server that defines the logic. Are you allowed to get in? What are your permissions? What are your rights? That's the application. Where's the content delivering stored? That's an application server. And of course, your information would be in a database. So I like to call it into this layer. The web server presents it to you. Your business logic runs on the application server, and the database stores your information. I hope that helps, because it's a great question, Ron.
So I'm guessing that this comment that Clyde just put in is clarification.
How does the app integrate?
Because you asked about clarification for what is this.
I still don't know what that means, Clyde. Think anybody on my team would know what that means?
So how this integrates to an instance. They're asking about how an app integrates with an instance.
Clyde, I really don't know what you mean, but if you're asking about how an app works with a virtual machine, then what we're talking about is somebody writes code and the code sits on the operating system, just like anything that you would in your computer. How does the app talk to a database over an application programming interface? Good. I hope I got
Okay, that's what
Okay.
they're asking about.
Okay.
APIs.
Okay.
Okay.
Does Apache Kafka have the same level of compatibility integrated with other services as HSQS? Apache Kafka is the industry standard and it's used everywhere. It's nothing to set up and use. Everybody uses it on all clouds and all data centers. Difference between standard queue and first out? Yes. Standard queue. Stuff goes in the queue, and as fast as it can be drained, it gets drained with no regards to message delivery. First in, first out. Number one message goes in, and number one message goes out. Number two message goes in, number two messages go out. Number three message goes in, number three message goes out. Good. Can the apps be accessed across? The apps can be accessed anywhere in the world, across any cloud that you want, as long as you've got IP connectivity and you set it up right. And I can't take too many unrelated. I can't really take unrelated questions, but I will do again the difference between a DevOps engineer and a cloud architect. And please join us tomorrow for the how to get your first cloud job on our. A cloud architect is a business executive. I'm going to say it again. It is a business executive who is at least 50 to 80% business and 20 to 50% tech, that designs, presents, and sells the solution. We never touch the data. We are not allowed to code. We are not allowed to configure. We are not allowed to touch the systems, ever. A DevOps engineer is a software engineer first, who then automates software release cycles in order to make software development more agile. DevOps and architecture have nothing to do with each other. They're kind of like a parrot and a lion. They're that different from each other. Can a FIFO lose data? Any queue can lose data if the queue crashes. But as a rule, it doesn't matter whether it's FIFO or first in or first out, unless the application or the database for some reason requires order delivery of messages. Is a load balancer needed for an app server? Sometimes. If you need more than one server for redundancy or performance purposes, which is generally yes, you definitely might want to use a load balancer before your app server. Okay, going back to the content. We're going to talk about extraction, translation, and loading tools. I'm not a database professional. I'm an architect and have been for decades. But there's times where you need to get data out of one database and put it into another database. And what we use for this is extraction, translation, and loading tools. AWS has their own. It's called Glue, which is okay, but it's proprietary. And there are other industrial grade ETL tools that you can use across all your clouds. And if you've got a lot of databases, because each database has its own strengths and weaknesses, and you wanted to pull information from one database to another database, you would use an extraction, translation, and loading tool. And Amazon has their own proprietary branded one called Amazon Glue. I don't really use proprietary anything when I don't have to, but they have one. It's a fully managed serverless tool. And, according to Amazon, it's real simple. You just point your data, the glue to your data. It'll automatically take care of everything you needed to worry about. According to AWS, that's what they're going to tell you. It discovers the data and stores the metadata in a catalog. And after the data is cataloged, it's searchable and queryable. The data can be queried or stuck into another database. What are we really talking about from an architecture perspective to see what it looks like? Here we go. We've got data, for example, and object storage. And then it's going to stick it anywhere we need, in which database we want, Athena, Redshift, EMR again. Map reduction is basically to take stuff in and out of one. Again, just Python Spark, not Amazon EMR in most cases. And then you could visualize the data with QuickSight, Power BI, Tableau, or some other data visualization tool. Now, if you wanted to take your data from your own database and then use one of these proprietary AWS databases, you could use something called the schema conversion tool. And what that does is it takes your data from your database, massages it so it sort of fits into an AWS proprietary database. Now, no schema conversion is going to be perfect. So if you use this, it's going to take some work and development work from your database team, but you can use this. And basically, it helps you migrate your database to a format that's compatible with your target database. And if you started out with a really bad database choice and you outgrew it, what you're talking about is this is a great way to get your information into a better database, like Oracle, for example, or MariaDB, or some non-proprietary database. Or you could use this to move it into a proprietary database, such as Amazon Aurora, but now you're stuck on a vendor proprietary system. But if you're already on an Oracle database, there's no reason to use this tool in the first place. It helps you get where you're looking for. So a schema conversion tool is really used to migrate between a heterogeneous database to convert the schema. And it basically helps with warehouse application codes and SQL procedures. It's a nice tool to help you actually get to your goals. And you use this type of a tool to move from one database to another. Now let's talk a little bit about high availability database design, at least as it pertains to your certification. In our Cloud Architect career development program, we get much deeper because we have the time. We spend between 500 and 700 hours training a cloud architect, because that's really what it takes to get your first job as an architect. We've got 15 hours here or less, so we've got to focus on what we can actually teach in this period of time, which is the exam. And I'm throwing in as many bonus nuggets of wisdom as I possibly can for you, because I want you to have the best. So, assuming a single cloud is highly available, which we don't believe in, but assuming you're going to put in a single cloud per your exam, we're going to talk about how they recommend you design a high availability database on AWS. As a reminder from yesterday, AWS designs their things into regions and availability zones. A region is a large geographic area, such as parts of Europe, or half of the US continent. By comparison, what we're talking about, and can you guys all still hear me? Chris, can you still see me? Because my YouTube that I'm using for monitor just went dead.
Yes.
Okay. So according to AWS, if you want high availability, you can put your databases into 2 availability zones, meaning 2 different data centers. And if one data center fails, you got a backup data center. Of course, if the cloud provider's network fails, if they get hacked, or the control plane goes down, you lose everything. But this is an AWS certification exam, so you got to know the AWS principles. So I'm going to tell you that a high availability database design uses a multi-AZ environment. So what happens is the database copies itself into another availability zone or data center. Now, by keeping a copy of your database in another availability zone, you do not get increased performance. It just has the information and it synchronizes it all the time. And should your primary database go down, the one or your data center go down, the backup in the other data center, otherwise known as availability zone, will take over. So you copy, a message goes to the database, send you the cat, bought some new cat food. Transaction stored in the database, it gets copied to the database in the next availability zone. So kind of keep that in the back of your mind and you are good to go. And it's copied synchronously. What does this look like architecturally? You've got the same thing in two different data centers. Your same web servers, app servers, and database servers. And what happens is your data is copied to the master, and it gets copied in availability zone A is copied to the standby in availability zone B. So that's really what we're talking about with regards to creating a high availability, if you want to call it that, database architecture in a single cloud. So let's say you've got your database in availability zone 1 and your database in availability zone 2. What's going to cause your database to fail over from data center 1 to data center 2? Well, if the primary database fails, meaning the server, guess what? It's going to shift to availability zone 2. If the entire data center goes out, like a power failure, because both power companies and both generators and backup generators and batteries backups fail, then poof, your information is going to go to the next one. More likely you have a network outage in the data center. If you change the database instance service type, poof, it's going to fail over. If you want to do maintenance like patch or upgrade the database, it'll fail over to the backup while you're doing the maintenance. Or if you issue a manual failover, I'm going to reboot this, reboot with failover, you reboot it and the backup one takes over, and that way you don't lose anything. Okay, we are now going to get to my favorite content, which is networking, but I'm going to pause for 5 minutes now to make sure that we don't have any other questions related to the database. Then we're going to get into the fun stuff, which is networking, which we're going to get a little geeky, I'm sure, but that's okay. It's my favorite.
All right, give me just a second here. Caught me off guard with the short slot there.
Yeah.
All right, here we go.
Can the same load balancer be used for the app server and web server in the cloud? Your app server and web servers are going to be on different subnets, so you're going to use a different load balancer. The database queue you mentioned, is it something that comes with as part of the AWS database feature, or it's an architectural concept? No, it's both an architectural concept and it's a server concept. So either you use a server like a Kafka queue, or you use the SQS service, but it is an actual functionality that is an architectural concept and a compute concept at the same time. So when would you use the schema conversion tool? If I want to go from my data center's Oracle server to Azure, Amazon Aurora, which I would never do, then I would use the schema conversion tool. Would I ever use Glue? No. But for your exam, if I want to pull data from one of my databases like Redshift and pop it into Aurora, I might use Glue because it kind of normalizes your data. And that's a great question, Sarah. So you're saying that ensuring high availability in multiple AZs, I don't call that high availability, but it is part of your exam. High availability in multiple regions. Guess what? Still not high availability because you got a single cloud. One hacker comes in and knocks down the cloud, and guess what? You lost everything. There's a big BGP problem on the AWS cloud, like the Google cloud was taken down from a BGP problem, or Facebook was taken down like a whole day from a BGP problem, or at least half a day or 8 hours, something crazy like that. Poof, whole cloud goes down. So I don't consider a single cloud ever a high availability system. I'm just telling you, what do multiple regions do? It puts your stuff halfway in the US and halfway in Europe. But if the cloud goes down, guess what? You're still done. So that's not really a high availability performance environment. Is a web server the same thing as a client server? No. A client server could be a web server, an application server, a file server. A web server is a type of server that serves web pages. Okay, we'll get back to this. So Chris or Alonzo, one of you guys in the chat box, if you can help me. There was a song when I was younger and it says, y'all having a good time? And then they go, dee, 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 dee. I don't remember the song, but if you're all having a good time, let's get back to this. Please give me a hashtag that says AWS Solutions Architect Associate, so I know you're awake, alert, and oriented, and blocked out. True high availability is never in a single cloud. It's like putting all your money in a single basket and then hoping that you don't get stolen from, or the basket doesn't catch fire, or you don't drop it, or you don't lose it, or nobody breaks into you. So no, single cloud is never high availability. So we're going to now get into some basic networking. And again, if you guys didn't hear the hashtag, if you guys can put hashtag AWS Solution Architect Associate. We're not fans of any kind of acronyms around here. Kind of keep that in the back of your mind. So let's do a basic networking review. No basic anything would start without the OSI model. The OSI, or the Open Systems Interconnect model, is a model that network engineers, network architects, cloud engineers, cloud architects, and anybody who works in tech needs to know. Why? Because, you've heard me be very unhappy with AWS marketing terms, or Azure marketing terms, or Google marketing terms. Why? Because they're complexity. Imagine a doctor trying to work in an environment where the same pill has 50 different names. How many people would die when Doctor 1 and Doctor 2 and Doctor 3 wouldn't even know they're on the same patients and the same medications? People would just die. And it's anything that matters depends upon clear language. And we must speak the same terminology if we want to be serious. If I walk into a chief information officer's office and talk about S3 and EC2, I will be fired. My replacement will thank me for the nice job, and I'll be escorted out of the room by security, because the chief information officer is not going to understand the gibberish that I'm talking about. Now, if I talk to the chief information officer about his virtual machines and his object storage, now we're on the same page. So the OSI model is standard language that everyone uses in the networking world. It's a means to get rid of garbage marketing terms, so we always can communicate. If I speak to somebody in Tel Aviv, guess what? And I talk about a layer 1 problem in networking, he or she is going to know. Now, if I speak to Tyrone in South Africa, guess what? And I say we've got a layer 2 problem, Tyrone's going to know what it is. And we must have precision language when we're dealing with precision anything. The network is the heart of the cloud. It's not software, it's the network. Network goes down, cloud goes down. And that's why organizations typically don't think of the network, and those that don't think of the network pay a big price in terms of outages. And anybody that knows networking knows you can't use a single service provider, because we've never been allowed to for decades. So let's talk about it, and I'm going to whiteboard it out for you because I want you to see it. I'll share my screen here. Layer 1, the physical cable between you and your switch. or your router, wire, whether it be fiber optic. So, on a wire, we're sending electrons, technically. On fiber, we're sending light. So layer 1 that we're talking about is the physical layer. Cable. Layer 2 is the data link layer. That's the actual hardware we're using. It's your Wi-Fi card. It's your Ethernet card. Hardware. Whether it was a serial interface for a WAN interface or an ISDN interface or an Ethernet card. So layer 1, wire. Layer 2, physical card. Hard-coded address. Hardware address. If you go to your computer, it has a MAC address. Layer 2 address. Physical, wire. Layer 2, data link, hardware. Now, next we move up to the network layer where we've got a logical address. Your IP address. 192.168.1.3, that is an IP address. Layer 1, wire. Layer 2, hardware card. Layer 3, logical addressing. You can't really change the MAC address on your computer, but you can change its IP address. Now, let's say we're talking about transport. The next layer 4 is transport. Do I send my data in a reliable fashion, meaning TCP? Am I sending UDP traffic for real-time traffic, such as voice or video? Or am I sending a test message, like a ping to Alonzo's computer? Ping Alonzo's computer like an ICMP echo, and he sends me an ICMP reply that he got me. Now, realistically, when it comes to network engineers and network architects, that's it. Layer 1, wire. Layer 2, card. Layer 3, logical address or IP address. Layer 4, TCP, UDP, or ICMP. But we're going to cover the rest. Now, at layer 5, or the session layer, we're dealing with something called the socket, which really controls the connection. At layer 6, we're talking about presentation of data, but there is some networking that occurs here. Encryption, for example, occurs at layer 6. And the applications are what you use. You go to your web browser, that is a layer 7 application. Think HTTP, DNS, SSH. So layer 1, wire. Layer 2, card. Layer 3, logical address. Layer 4, protocol, TCP, UDP, ICMP. Layer 5, session. Layer 6, presentation and encryption. Layer 7 is the application itself. Now, when it comes to networking, whether it's in the data center, whether it's in the cloud, it's completely irrelevant. Everything needs an address. Why do you need an address? You need to be able to communicate with the system. Let's say, for example, I wanted to send Eva Doikja a letter and thank her for some of the really great blogs that she collaborated with me on. And by the way, on our website, there's some really great Cloud Architect interview questions blogs. Eva Doikja worked very closely with me on that, and she wrote a beautiful article on edge computing. I recommend everybody read. So how are you going to know how to find it? Well, you got to know to go to www.gocloudcareers.com. Otherwise, you're not going to see these great articles. If I wanted to send a letter to my mother, I need to know her address. How else will the post office know how to send my letter there? Well, when it comes to message delivering in computers, we need an IP address. It's basically no different than the address in your house. And every address on your network must be unique. How would the mail system work? 123 Main Street. I have a 123 Main Street in Philadelphia, Newtown, Bucks County, then Salem, Bucks County, Levittown, Bucks County. Every city in the world has like a 123 Main Street, okay? But what's different that makes that unique? The postal code or the zip code. Same thing with IP addressing. Every device needs a system that's going to talk to each other, which must be unique. Now, inside of your system, you can use private addresses, but they must be unique inside of your organization. And anything in the external internet also needs to be unique. Now, when we deal with IP addressing, we're going to deal with two versions, IPv4 and IPv6. IPv4 is the 32-bit address that we've been using for as long as I can remember. I've been using it since the late 80s. And IPv6 was actually invented a long time ago, but we're starting to use IPv6 addresses. The world still hasn't even adapted 30, 40 years later. So when you pop addresses for your VPC, inside of your VPC, you're going to use private addresses. If you want to know private addressing and you truly want to understand it, I recommend you read, and you should all read this, the Internet Engineering Task Force, RFC, Request for Comments, 1918. That is the specification for IP addresses that all network architects like me use. And inside of that, they specified that internally, because we don't have enough IP addresses, organizations should use the 10.0.0/8 address space, the 172.16.0.0, all the way to 172.31.0.0, all /16s, which can also be summarized or aggregated into 172.16.0.0/12, and the 192.168.0.0/16 address space. These are private IP addresses to be used inside your organization, and they are not globally relevant. I'm going to mention this right now just because we're going to talk about classless interdomain routing for a little bit. We used to have these things 30, 40 years ago called IP classes. And that was basically meaning where every single network used a specified subnet mask. So let's say we had the 1.0.0/8 network. We had 16 million addresses on that address, but here's the problem. Every card on our router needs to be on a different subnet. So if we used 4 different /8s or Class A addresses, we'd be burning through 64 million IP addresses. Eee. Now the Class B address space had a /16 and was from the 128.0.0 all the way to 191.255.255.255. Now guess what? If you do that, each subnet uses 65,534 addresses, or 535. I think it's 534. And that would basically, if you had 4 different subnets or routers on a card, you would actually burn through 260,000 addresses. Again, it would be ridiculous. Now, a Class C address, which had a /24, which was from the 192.0.0 all the way to the 223.255.255.255.255/24, would be 254 addresses. And of course, there's the Class D address. Spaces were used for IP multicast, and that's the 224.0.0.0 and the 239.255.255.255. Nobody uses IP classes. We're using classless interdomain routing since then, and that really means just subnetting. Modern times, classless addresses, and routers are going to build a map of the network. And what happens is routers are going to have a table in them, and they're going to say to reach the 192.168.1.0/32, take interface X. To reach the 192.168.1.4 subnet, takes interface Y. To reach the 192.168.1.8/32/30 subnet, reach, because they're all /30 subnets I'm giving you right now, take interface Z. And that's what we're talking about. And that's what we're talking about is subnetting, because we have to optimize our IP addresses space and we can't waste it. Every interface needs to be there. So let's say, for example, we used a single Class C IP address, 192.168.1.0/24, which gives us 254 hosts. And we had one subnet, which was the 192.168.1.0/28. And then the next subnet would be 192.168.1.16/28. And then the next subnet would be 192.168.1.32/28. And I did a free subnetting webinar. Somebody from my team posted a free subnetting webinar inside of this chat box to help people get to their goals, because I can't cover the 4-hour subnet webinar over here. But I'll show a couple of examples. Here I decided to create /28 to that same IP address that I showed you. And you can see the different subnets. Actually, do you want me to do a subnetting webinar? If you want me to do a subnetting webinar, do two things. Type #subnetting webinar, and also Chris will do a poll to see if we get enough of you. We'll probably do a subnetting webinar.
Yeah, I'll put a poll in the chat box for everybody if you want a subnetting web.
So let's see how many people poll it and how many #subnetting webinars we get. Because if you want it, I'll do it. I don't know when we'll fit in the schedule, but I'll find a way to do it. And as you can see, I subnetted the /28 into multiple smaller subnets. Now, if subnetting is taking a big network and chopping it down to little networks, of course, we got to do the opposite, right? We've got to be able to take multiple small networks and bring it into a single big network. Why would we do that? Let's go back to what I just showed you. See how we have all these /28 subnets? Now, if you've got a direct connection to AWS and to your VPC, you can only give them 100 routes. Could you imagine? We've already using all these routes over here, but we can summarize that into a single route, because when we only have 100 routes, we've got to get real creative. So supernetting, which is done for route summarization to reduce the memory load on the routers and the CPU load on the routers, is the exact opposite of subnetting, and it is absolutely critical anytime we're dealing with those. You're only going to hear this here. You won't realistically, you'll barely see it on an AWS Advanced Networking because it's so basic, it's not even worth your time. But you need to know how to do this. Our architects need to know this, because if they get this wrong, the whole system falls apart. So supernets take many small subnets and combine it into a giant subnet. And it's really done for the router. So here's an example. Here we've got 192.168.0.0, 192.168.1.0/24, 192.168.2.0/24, and 192.168.3.0/24. And then we summarize that into 192.168.0.0/22. This is classless interdomain routing. Subnet down, supernet up, and it's all related to your traffic engineering that your network architects and your cloud network architects and your cloud network engineers need to be careful of. And believe me, without the cloud networking people, everything will fall apart. Next thing we're going to deal with is IPv6 addresses. Again, it is a new form of IP addressing. New is in the last 20 to 30 years old, and people are starting to use it. Like everything in tech, it moves super slow. We all think it moves fast because the marketing vendors keep changing the name of the same old things. But the things that I worked on in 1996 are the same things I worked on today. Of course, now it's better, faster, cheaper, and more reliable. But there is that. So IPv6 addresses are just a newer form. And every interface, as I mentioned previously, is assigned an IPv6 global address. Where do we typically use IPv6 addresses? Mobile phones. Now, if IPv6 addresses were a 32-bit binary, meaning 0, 1 for 32 bits, IPv6 uses a 128-bit hexadecimal address. Binary, 0, 1. Hexadecimal, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alpha, Bravo, Charlie, Delta, Echo, Foxtrot. So we got 16 versus 2. So 16 to the 128th power versus 2 to the 32nd power. See the difference here? I'm talking scalability, hugeness. Chris, the next thing that we want to cover is the virtual private cloud, otherwise known as the virtual private data center. Where am I time-wise?
You've gone for about 20 minutes.
Okay, let me take a few minutes of questions before I get to VPC. Good question. What's the difference between a high availability failover site and a disaster recovery site? A failover site is you have a data center over here, and you've got a data center here. And if this fails, everything goes to this one. That's high availability failover. A disaster recovery site is the complete and total or partial backup of your systems, either ready to go for failover or in a manner where it's just stored and not ready to go. So for example, if I'm going to use a physical data center, and I've got two data centers, one in New York and one in New Jersey and one in Philadelphia, I've got three data centers in a close proximity. If a nuclear bomb were to attack, or a massive earthquake that covers that small area, or a massive hurricane were to come, let's not use it, and all those environments go down, I'm done. Now, by comparison to a high availability failover site, a disaster recovery site is typically like 1,000+ miles away. And it's owned by different people under different people's control. So AWS would say, hey, you could have your stuff in US East and US West, and you can back it up to Europe. And then when the AWS code goes down, you got nothing. Something my grandmother would call bupkis, for those of you that know what I mean. By comparison, if I was using the AWS cloud and the Azure cloud for high availability, I might store all my data into Google. And that way, and all my virtual machines into Google. And that way, if AWS failed and Azure failed, I got a backup cloud. It will be on your exam, but you should never, ever, 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 ever do your disaster recovery in the same cloud as your systems. Because that's like putting all your eggs in one basket all over again. So hope I answered your question there, Espat. What's the main difference between TCP and UDP? Huge difference. TCP is reliable. So Chad, I send you a message and you say, got it, Mike. Send me message 2. I send you message 2, and Chad, you say, got it. And then said, if you got 2, let me speed it up. I'm going to send you messages 3 and 4. And you say, got them. And then I'm going to send you some more. I'm going to send you messages 5, 6, 7, 8. And you're going to say, got it, Mike. And then I'm going to send you 9, 10, 11, and 12, and you don't respond. So I'm going to resend you 9, 10, 11, and 12 until you respond. Of course, I'm going to slow it down and only send you one message after you lost one. By comparison, UDP is me sending you data as fast as I can, and I don't care if you receive it or not. So if I'm going to send you something really critical that I need acknowledgement on, it's going to be sent via TCP. So TCP is typically sent for files, for example. Now, what if it's voice? What if I said to you, my cat Cindy is beautiful? And you lost the word my cat, and you got my cat Cindy is. You lost is and got beautiful. My cat Cindy beautiful. That's voice. It's like your cell phone, for example, or video on Netflix. It pixels up for a second and it goes back to normal. That's supposed to be. But TCP retransmits. So now what if I said to you, beautiful is my cat Cindy, because we lost some of the messages and we said, you might still be able to interpret it, but so for voice and video, it's always UDP. For reliable transport of anything mission critical, like a file, it's always done via TCP. Great question. A good failover site, Florence, runs at the same time as the original site, and the data should be synchronized and identical. Yes. Good thinking. Kyron Charles, what are the limitations of IPv4? Realistically speaking, the number of IP addresses, 2 to the 32nd power. Major problem. Otherwise, it's perfect. What are some challenges associated with transitioning from IPv4 and IPv6? Readdressing your systems, setting up the routing protocols, and rebuilding the routing tables. That doesn't sound like much, but I'm going to tell you, CCIs like me have been cleaning up people's IP addressing scheme mistakes for decades. What happens is typically they have somebody that's like a sysadmin or a programmer that thinks they know IP addressing. And it's not that these people aren't smart. Programmers know programming. Sysadmins know systems administration. And the person that sets up the IP addressing plan needs to be the best network architect in the entire building, because it takes so much networking capabilities in order to be able to do these things. They need to be the most senior person, because IP addresses are kind of like the roads in a city. If the roads are designed poorly, traffic gets traffic jammed all the time. So the readdressing is the main plan, and resetting up the interior gateway protocol such as OSPF or intermediate systems to intermediate systems to deal with it, and the exterior gateway protocol such as BGP to deal with the new IPv6 address family. Not that it's nothing to somebody like me, because I've been dealing with this forever, but it's something that's going to take the help of a strong network engineer at minimum, or a great network architect. Good question. How do you create an IP address? I don't know what you mean by that. How do you assign an IP address? It's going to typically done via DHCP or dynamic host configuration protocol. Okay, I'm going to get back to the content, but if you want a subnetting webinar, please vote for the subnetting webinar. So vote for the subnetting webinar. Let me know. Hashtag AWS Solution Architect Associate, as well as, click on that vote for the subnetting webinar. I know your way. So we're going to, the AWS VPC section is pretty deep. And because we're now dealing with your virtual private data center, which was all that the cloud is. What I'm going to do is cover as much as I can today. We may go over a little bit, because I'm trying to avoid Saturday for everybody, and I want to give you guys, even if we go a little longer. So let's talk about the components of the VPC. It's routing. It's routers that connect to the internet called internet gateways. We'll talk about egress-only internet gateways, not instances and not gateways. We'll talk about elastic IP addresses, VPC endpoints, VPC peering, access control lists, specifically network access control lists, and security groups. To begin first, let's talk about routing tables. How do you get your traffic to its destination? The routers do it. So how do the routers do it? Typically speaking, they run a little protocol. They all talk to each other, and they tell each other their routes. They build a map of the network. And when it comes to routing, there's going to be two ways where you can build your routing tables. Option one, you manually tell it. So for any of you that are like 50, or I'm not quite 50, but any of you guys that are between 40 and 65, perhaps you remember you wanted to go to your friend Billy Bob's house, or Julie's house, or Sarah's house, and you didn't know where they lived, and they gave you their address, and you picked up a physical piece of paper map, and you looked at it, and then you wrote down some paper that said, I-95 for 22 miles north. Get off at the I-95 exit, take Route 222 for 3 miles east, then make a right onto 123 Main Street, and her house is at 22 123 Main Street. We wrote it down via paper. Guess what? That was great. And then poof, we're trying to drive to our friend Julie's house, and the road is blocked by police officers. Now we don't know how to get there. And they're pointing you to some detour, and you get lost, and 4 hours later you get there, you're all frustrated. So you're just not happy. Came the invention of the GPS. Recalculating, and they got you to the destination. So with routers, we've got two options. We can use a dynamic routing protocol called BGP. Make sure you follow me on LinkedIn. Pop this thing out. I'm going to get you some unbelievable BGP training completely free. I'm going to release it real soon. Follow me on LinkedIn if you want to get it. And so realistically speaking, anything that matters is going to use dynamic routing protocol. But the routers are going to build a map, and here's what the map is going to look like. It's going to say, hey, to reach the 172.16.1.0 subnet, it's right here. I'm already on that subnet, so it's local. To reach the 192.168.0.0 subnet, use this interface. Papa Charlie X-ray 12345 6. To reach the 192.168.1.0/24, which is more specific than the previous one, reach the Papa Charlie X-ray 654321 interface. I want to go to the internet. Look, notice we have what's called the default route, so all zeros, which says if you don't know where to go here. Reach Internet Gateway, India Golf Whiskey 123456. So kind of keep that in the back of your mind. I use phonetic alphabets constantly because, again, I'm all about precision language, a language that's used in every country in the world to make things simple. Now, what is it looking like in the enterprise? I wanted you guys to have some more knowledge. Typically speaking, we're going to have what's called an interior gateway protocol that's optimized for speed. And, there were lots of internet interior gateway routing protocols over the years. There was RIP, there was RIP v2, there was IGRP, EIGRP, OSPF, intermediate systems to intermediate systems. In today's world, it's either OSPF, which is what most enterprises uses, or the global internet service providers will use OSPF or intermediate systems to intermediate systems. So what you'll see is these are dynamic routing protocols. The organizations themselves internally will run their own interior gateway protocol that's optimized for speed. And they'll run what's called an exterior gateway protocol, which is what's used to connect to external entities. So, interior gateway protocol locally, exterior gateway protocol between things. When an organization connects their data center to the cloud, inside of their data center, they're running an interior gateway protocol like OSPF. And when they connect to the cloud provider to exchange routing information, they're using BGP because that's really the only exterior gateway protocol we use in modern times. So that's the way that kind of looks. And I'm going to briefly graze over BGP because it'll take me at least 4 hours to do a BGP workshop. And I've got a really beautiful document coming for you. Please follow me on LinkedIn. You don't want to miss this document. So when you're connecting to AWS over, say, your direct connection or potentially even a VPN, you've got to find a way to exchange routing information. Why? Your data center won't be able to reach them if you don't have the routes, and the cloud won't be able to reach your users if it doesn't have their routes. So you need to get the routing right. And it's going to be via BGP. And AWS, as well as all cloud providers, support connecting to them via BGP because it's exterior organizations and the cloud provider is exterior to you. We use BGP because it's incredibly tunable and highly scalable. We can do all kinds of traffic engineering. Hey, take this link to go here, take this, and load share back and forth. BGP is amazing. It's beautiful. I've got over 10,000 hours of experience with it, and I love it. And I use it for everything, as do all network architects. Test question for you. You might see it. You'll definitely see it on the AWS Advanced Networking, which you don't recommend you take because it's too basic. You'll likely see it on either the Certified Solution Architect Associate or Professional. Probably the Professional, but you may see it on either one. BGP uses TCP port 179. I'm going to say it again. BGP uses TCP port 179. Why do I say this to you? Well, chances are you're going to have a firewall, right? Or an access list somewhere for security. If you need to connect and you've got a firewall between you and AWS, and you don't allow TCP ports 179, guess what? BGP connection will close. No traffic will get anywhere. Also, with BGP, you will require an autonomous system to identify your organization. When you connect to BGP, you must use it with direct connections, and there's a tremendous amount of tuning options. That document that I'm releasing will explain every last one of them. AWS also supports the community no export, which is great if you don't want to become transit, which is way beyond the concept here. It's also far beyond the AWS Advanced Networking. We're getting into CCIE concepts, which I can't do in this short period of time. But what it means is this. If I tell Chris information about my routes, and Chris tells Alonzo information about my routes, Alonzo can reach all of my routes through Chris. That's called transit. If I tell Chris, do not tell Alonzo about any of these routes, Alonzo can't reach me through Chris. So the no export community means don't tell your people downstream or upstream any routes that you've learned from this provider. And AWS supports that. AWS implementation supports very basic BGP implementation, but they do support weight, local preference, AS path, specificity, routing information, etc. And they only will let you use 100 routes. So 100 routes is nothing. I worked on networks years ago that had 20 and 30,000 routes, and that's before when routers were small with like a couple hundred megahertz CPUs in them. Kind of put that into context. Megahertz. So it's all about using the right IP addresses. Let's talk about an internet gateway. What's a gateway, everybody? It's just a router. A gateway is a router. So if you want to connect to the internet, you need a router that connects to the internet, right? So AWS calls the routers that connect to the internet gateways. Good logical term. Truthfully told, it really is. And AWS will tell you there's no bandwidth constraints or performance limitations in your internet gateway. There's always performance limitations, but for the most part, it's about the speed you need. And it's just a router that connects you to the internet. Here's how you create one. It's very simple. You basically go to the management console CLI and you attach an internet gateway to your VPC, which is your virtual private data center. You create a default route, which is that 0.0.0 route, and you send all unknown traffic to that internet gateway. You need a public IP address on the internet gateway, as well as any systems that need to be reachable from the internet. Now, an internet gateway means the systems that are behind it with a public address are reachable from the internet. Internet gateway, reachable inbound and outbound from the internet. Ooh, both ways. Now, what do you guys think this means? It means hackers can find you. Hackers can find you. So, internet gateway means you're available to be hacked. So, use the right next generation firewalls, intrusion detection, intrusion prevention systems, etc. Set up your demilitarized zones intelligently. None of that's covered in the AWS Certified Solution Architect Associate or Professional, but if you're going to be an architect, you need to know these things. We teach it obviously in our Cloud Architect Career Development Program. So just understand, internet gateway means reachable in and out. What's it look like over here architecturally according to AWS? Looks very simple. Here you've got your virtual and private data center. What you can see is you've got some virtual machines. Let's say they're all behind a load balancer behind the router. The public address on the load balancer would have this IP address of 3.3.3.3. It's a public address, which is routable to the internet. All systems behind this, which all fall in the CIDR range of 172.16.0.0/16, if they don't know what to go, they look at the routing table. So just look at this. You can see two subnets over here. 172.16.2.0/24, which the routing table shows as local in the upper right-hand corner. The 172.16.0.3.0/24 is also local because it's inside of our environment. And there you go. That's your default route, 0.0.0.0/0, which says if you don't know where to go to the internet gateway. That's all we're talking about here. Same thing we've done in routers. So internet gateways allow ingress, which means coming in, and egress, which comes out. Traffic comes in, you can be hacked, so secure it accordingly. Now let's talk about something called an egress-only internet gateway. Egress means it allows your traffic to go out, but it doesn't allow any traffic to come in. So an egress-only internet gateway is designed for your systems that use IPv6. And it allows your systems to go out to the internet, maybe update their operating system, download patches, etc. But it doesn't allow external traffic in, so it's much more secure than using an internet gateway. I'd still be using firewalls and things behind it anyway, but keep that in the back of your mind. Internet gateways are stateful. What does this mean? So here's the thing. I'm sitting behind my phone. My phone just became a firewall. And I want to go to the Cindy.com website to see photos of the beautiful Cindy the cat doing cat things, jumping up, sleeping, whatever Cindy the cat does. She has all kinds of fun per day. She looks like this, by the way. But my phone is the firewall, and I want to go to the Cindy.com website. I type www.cindy.com on my website. The DNS tells me the IPv4, IPv6 of the website, and my traffic hits my default gateway, goes through my firewall, and out to the internet. Now, when I stuck my traffic through the firewall paid attention to me, and it says Mike Gibbs is going to www.cindythecat.com. So my request goes through the firewall, it pierces the firewall, it goes out to the internet, to the Cindy.com website. Cindy.com says, here's the photo of me you requested, Mike, or Daddy, whatever you want to use. It goes through the firewall, and it comes back to me. Why is her traffic allowed through the firewall? Because the firewall has a table that says, Mike Gibbs went to www.cindy.com. Cindy.com is answering Mike Gibbs, so allow the traffic in. Now, conversely, we now have a hacker on the internet that wants to get to Mike Gibbs's computer that's behind the firewall. He or she sends their traffic to the firewall, to me, to the firewall, and the firewall says, denied. Next hacker comes in, denied. Next hacker tries to come in, denied. And why is that? Because the firewall doesn't know about it. It has no state. So state is merely tracking what happens. So, excuse me. If the firewall saw me go through the connection, it remembered it. It's stateful. That's what stateful means. So egress-only internet gateways allow your traffic out to the internet and returning back, but it does not allow inbound connectivity. And that's typically used for your host to get patches. NAT instances. Well, realistically speaking, NAT instance is something that you could, in the old days, you would have stuck behind your internet gateway, which would translate your private addresses into public addresses. Now, the reality is AWS is a better service called the NAT Gateway. We'll get to this, but you might still need to create your own version of a NAT instance, even if it's not an AWS NAT instance. NAT translates one address to another. Why might you need to do this? Company A addressed their systems using 10.0.0 address space. Company A is a big, strong, powerful company, and it just bought Company B. And guess which IP addresses Company B is using? 10.0.0/8. Now, I told you your address space needed to be unique between them. So, if Company A wants to talk to Company B and they use the same IP addresses, you got a problem. Doesn't work. So we might use NAT, or network address translation, to translate these addresses into different addresses so the systems can talk to each other. And there's multiple forms of NAT, one-to-one NAT, one-to-many NAT, static NAT, dynamic NAT, PAT, and most of those aren't even covered in the AWS Advanced Networking, but you may need to do them. So critical information for the cloud architect or the cloud network architect. And that's why we have training that's way beyond this, but we're focused on certifications and I want you to pass the exam. So a NAT instance is available as an AMI, meaning an image that you can use from AWS, or you could create your own NAT instance if you needed to do NAT. But if you're going to use NAT connecting to a NAT instance to connect to the internet, you have to put it in a public subnet, and basically it's going to have a default route to the gateway, and all your hosts will have a default route to the NAT instance, which will then have a default route to the NAT gateway. And it's going to look like this. You've got your users in a private subnet. They want to go to the internet. They have a route that says go to the NAT instance. The NAT instance sends your traffic to the NAT gateway, which sends your traffic out there to the internet. Now, that was getting pretty complicated. So AWS decided to come up with a simpler solution, and they came up with a NAT gateway, which is a fully managed NAT service. The NAT gateway connects you to the internet and translates your private addresses into a public address. Now, NAT gateways do something that's called PAT, or port address translation, that's also known as NAT overload, where they translate a tremendous number of addresses into a single address. And they do that by using an IP address plus a port number to separate each IP address. If you want to know more about that, we've got a free CCNA course that you can actually see on our website. My team can pop a link to that. So what happens is a NAT gateway is fully redundant inside of availability zones. If you've got 2 availability zones, guess what? You need 2 NAT gateways. You put it in a public subnet, and it's got a public IP automatically assigned to it for the life of the gateway. And basically, you just give all your systems a route to the NAT gateway. It's kind of like a NAT instance and a NAT gateway all in one, without you having to think about the security concerns to the same degree as you would with an internet gateway, which basically provides full internet access behind the NAT gateway. So your systems are here, you attach to the NAT gateway, and it provides internet access and NAT services, network address translation, at the same time. Now, on your computer, if you want to connect it to the internet, you got to plug it into the network, right? The Ethernet card on your computer, or you could use Wi-Fi. Tip, secret here, if it matters, you don't use wireless ever. You're not going to see a data center built on wireless. They wire things out. If you want to go see a concert, chances are most of the stuff behind the scenes is going to be wired. Certain things are going to be wireless, that they have no choice, but most everything's going to be wired. Why? Because wires are more responsible than wireless, are more reliable than wireless. So every computer needs to be plugged into the network. And what's it use? It's called the network interface. So when we deal with AWS, their marketing folks call it an elastic network interface. An elastic network interface is just an Ethernet port or a virtual Ethernet port. And by default, you basically would set up, you turn on your system, and it comes with one network interface. Now, there are times where you might want to put a system on 2 different subnets at the same time. And you can basically put 2 hosts. And if you did that, 2 subnets means 2 interests. You'll see a lot of people teaching you to do this with a Bastion host, which is one of the worst security things you could potentially do, except for not the Azure Bastion host, but the way most people do it. I'm not even going to cover that. Just don't make a Bastion host. We've got a video on why you shouldn't create Bastion hosts, at least for most parts, like they teach in the certification. But done intelligently, it can be used. Well, actually, there's no intelligent way to do it. What happens, what a Bastion host is, you stick a host on the internet, on the public internet, with 2 network cards, and it's got a backdoor into your private systems. You can SSH this thing on the internet, wide open on the internet, and then you can backdoor into your systems, but so can any hacker. But there are business reasons. Maybe you've got users on 2 different subnets that need maximum performance, and you don't want to route between subnets in your router. There are reasons you multi-home thing. Or you could create a private management network and manage things over the management network. There's lots of reasons you need a multi-home servers. Now, if you need a public address, like on a web server or on a load balancer, if there's multiple web servers behind it, the load balancer will get a public IP address. You're going to need one. So what do you think a public IP address is called? An elastic IP address, because the marketing term loves the word elastic. So what is an elastic IP address? It's a public address that you borrow from AWS, and you keep it as long as you need it. And when you're finished with it, the address gets returned to AWS's global address pool, and it gets given to another user when they're ready. An elastic IP address can be a single public address. It could have a public address that's mapped to many private addresses, as with NAT overload, otherwise known as port address translation with a NAT gateway. And you can set it up in multiple ways. Here's what it actually looks like, architecturally speaking. You can see you've got your systems, and the systems basically have a public IP address. That's it. Chris, how long have I been talking?
Not sure, actually. I just assumed you were going to be finishing out, but it's been about 20, maybe 25 minutes, maybe.
Okay, what I'm going to do is I'm going to cover endpoints And then after endpoints, I'm going to stop, but I'll take some questions, and I think we probably should finish from there, unless people want a little more. So let's discuss endpoints. Endpoints are a way to connect things to each other. That's why it's called an endpoint. And we're going to be dealing with two kinds of VPC endpoints. And endpoints are used to allow your VPC to connect to another AWS service or another network. We use endpoints because their performance is better, the latency is lower, and the security and cost is better than going to the internet. Here's an example of an endpoint in its action. Let's say you've got your VPC, and your servers there want to communicate with object storage, otherwise known as AWS S3. There's two ways you could do it. You could send your traffic out to the internet and back into S3. Now, the internet's not secure, so you'd have to encrypt your traffic. And here's the scary part. You have to pay to send your traffic to the internet. Internet performance is slow and not guaranteed, and then it would come back to AWS. Or you could do the other option, which is you could just send your traffic across the AWS network. And that's the point of the endpoint communication. You have no control over the AWS network, but you have no control of the internet, and you have no control over the AWS network, but AWS can control the performance of their network, but they can't control the internet. So endpoints are going to have lower latency, better communications, etc. So endpoints are really virtual devices that are, because they're virtual, they don't go down, they're high availability, assuming the cloud doesn't go down. We're going to talk about two kinds of endpoints, gateway endpoints and interface endpoints. Gateway endpoints provide high-speed access to AWS services, like S3. And the way it works is it creates a route to the service and puts the route on the routing table. And it allows private access from, say, object storage to your VPC and vice versa. When you create an endpoint for S3, what happens is a prefix list and a VPC endpoint are created. The prefix list will adhere to the naming convention of and it's going to look like Papa Lima PL dash, and then you're going to have a bunch of whatever it needs to be, things coming after that, like X-ray, 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 etc., and then be placed in the routing table. And that way, the routers and the VPC, the virtual routers, will know if you want to reach S3, go that way. So let's talk a little bit about securing an endpoint. You're going to set up an endpoint policy that's going to limit resources that are available to the endpoint. Remember, if you don't have a route to it, you can't reach it. So only limit your routing information to the subnets that need it, because if you don't have a route, you can't reach it. So that's a great way to start with some security right then and there, quickly, cheaply, and easily. Next, we'll discuss interface endpoints. Now, interface endpoints are a way to connect to different AWS services or other organizations. So let's say EC2 Systems Manager, Kinesis, load balancers. Maybe you're a car manufacturer and you make a car, but you got a tire manufacturer and a battery manufacturer and a steel manufacturer all on AWS, and you want to connect to them directly across the AWS cloud. That's why you're using an interface endpoint. And interface endpoints work a little bit differently than the gateway endpoints we described. What happens when you create an interface endpoint, it effectively creates a network interface on your VPC that's local to your VPC. And use that interface to connect to the third provider. AWS will automatically generate a DNS name, so you don't have to remember the IP address, and you can connect to it via the name. Interface endpoints actually use the AWS private link service, which is a one-way, like pseudo wire or virtual wire to connect to things across the AWS network. It's like a virtual private line. And the private line creates these network interfaces that you use, and it restricts all traffic going across the endpoint between your VPC and that service or the customer or partner. What does it look like architecturally speaking? Let's say you've got your VPC and you want to reach a service provider VPC. And the service provider of VPC is VPC2. What happens is you create a VPC endpoint and you can reach the systems inside of VPC2. I'm going to stop there because VPC peering is another concept, and I think I've been speaking a long time, and I don't want to confuse people. Chris, are there any questions for me? I'm sure there are.
All right, let's see if there are questions.
I'm worried we covered so much and people are getting tired.
Oh, we got comments on the cat.
Thank you. Oh, we love my cat, Cindy. She came into our house like a storm. I bought her for my wife because my wife loves cats. And the next thing I realized, the cat's sleeping with me, following me from room to room. She's special. How do you recognize an IPv4 versus IPv6 address? Leo from my team did a great thing. An IPv4 address is going to look something like 10.0.1.128. Whereas an IPv6 address is going to be in hexadecimal, and it's going to look like 2002, and it's going to look like 0 Delta Echo 7, for example, and you'll see another colon. It'll be Alpha Bravo Charlie Delta colon, and then you'll see like a 001 thing, and it'll go on for 128 bits. Great way to do, great example, Leo. Does endpoints use patch cables? No, these are virtual things. So between every server, they're going to be plugged into switches, typically two that are going to be plugged into the routers. The routers are going to have cables in between each router. But the endpoints are virtual. They're going to use the IP network that's already been established. Good question on Tech Electric. For the endpoint, they must have IP connectivity. Everything's plugged into the network, which means you need a network. Just to confirm, you can access your S3 bucket from an EC2 instance, and a private sub must be a gateway endpoint. That is correct. You could also go out and reach it through the internet if you wanted to, but that wouldn't be efficient. Are there any implications using an AIP? No, not at all. That's your only option. When it's recycled back, well, the implications are, if you wanted to use a different one, you'd have to update your DNS mappings and things like that. Kind of like when you go from one service provider to another, but everything else will be okay. You just have to change your IP addresses and your routing. Well, you don't really have to do so much with routing on the cloud. It's much easier. And your DNS. Good question, though. Are there cases when you would prefer an interface, a gateway over an interface? Yeah, you have to use it based upon what you're using. If you're connecting to external clients, it's an interface endpoint. If you're connecting to S3 or DynamoDB, I think it's S3 definitely. I think DynamoDB also uses a gateway endpoint. Everything else uses an interface endpoint. Good question. Okay, so I do want you to I want to make sure you read the book as well. You know, in the book, we have the ability and the time to provide even more content. And there's a relationship between the content that we're discussing here and in the book. In the book, we're giving you much more focused AWS content for the exams. And I'm giving you as much non-AWS content as I can in the time permitted. But I'm still making this boot camp focus. So I want you to read the book. I want you to practice the labs. And I also want you to watch all these because I want the best for you. To endpoints to point IPv6, it's kind of a weird route that they're putting in the routing table. Remember I said it's a prefix list, comma XXXX, so it's something slightly different. Does AWS generate the DNS? Yes, absolutely, for your endpoints. How do you secure BGP routing information and prevent unauthorized changes to the routing table? Well, you can do certain things, like you can set up MD5 message authentication, which is not the greatest in the world. You manually assign your BGP peers, which is something. But what you typically want to do is you typically want to set up your BGP policy with either a distributed list, for example, or a route map that you're only accessing routes that come from the subnets that you're supposed to. And that way you're generally there. There's some very good guidance on acceptable ways to use BGP. But there, and I actually have an article that I wrote on for Hacker Noon on how to secure your BGP as well, and BGP hacking and hijacking. But kind of keep that in the back of your mind. Yes, those are the kind of main things that you can do. It's not a lot, but the message, the BGP peer authentication, the fact that you manually define the peers, and if I know that I'm going to receive the 172.1.6.0.0/19, I'm only going to take in routes from that and not allow any other routes to be injected into my systems. And the cloud provider would do the same. Good question. What is the AWS backbone? It's their high-performance, high-speed network. Strong question there. Please download those. And most importantly, tomorrow, there's a lot of questions on careers. And there is a massive difference between certifications and getting hired in today's world. I want you to get hired. I want you to earn a lot more than you dream possible. And it's very easy to do if you know exactly what to learn. And most of those things are not in certifications, and all of you can do it, regardless of your background. So please join us tomorrow on the Become the Ultimate Cloud Architect webinar. Not only will we present for about 30 minutes, but we will spend an additional 90 minutes answering your questions live. To kind of keep that in the back of your mind. And we can do it face to face. And if you've had a good time and you're learning, please hit the like button. Please subscribe to our YouTube channel and hit the notification bell so you'll be notified when we do these things. And, it costs as much as buying a new car to put on one of these productions. And we do it to help those that can't afford training, because I really want to help the entire world build their best career. Please share this. Tell your friends to take this course. We're keeping it live on YouTube completely free. So please send an email, a tweet, make a LinkedIn post. We put a lot of time, effort, and money in this. There's about 7 members of my team working on this right now, let alone the hundreds and hundreds of hours behind the scenes to put something like this together. Please share this so we can help as many people as possible. BGP will have to be configured on both sides. BGP is only configured on routers, not switches, unless it is a layer 3 switch, which is really a switch router combined. So thrilled that you're there. Sarah, thank you so much. I don't know what you mean by that, but anybody can follow this course. I don't care whether you take the certification or not. I care that you get the knowledge. And I've got people getting hired as cloud architects every single day. And some of them never even took a certification exam, but they're trained for that job. And they don't need any fancy education. They don't need any experience. They need it. So read the book and watch this course again and again. Each time, I promise you'll pick up other things. Sam S., thank you so much. Alayomi, thank you so much. Alonzo, another awesome way to end Go Cloud Bootcamp. I think so, Alonzo. I hope so. Owen, thank you so much. Chris, thank you. The Go Cloud Architect team is thrilled to help. David, we're thrilled to be here for you. Karen, thank you. And team, Mike and team, thank you so much. Thank you. I'm all having a great time. Alonzi, do you remember that song, Y'all Having a Good Time? If so, put it in the chat box because it was driving me nuts. Not the Pitbull version, but the original version. I like the Pitbull version. So, thanks, Jason. Thanks. Which webinar is that for tomorrow? That is the How to Get Your First Cloud Architect Job. And not only will tell you how to get your first cloud architect job, but how to be great at it so you can have a great career. Thanks, Lady Godiva. Thanks, Jim. Thank you, Greg. Mike. Thank you, Saeed. Sam, we appreciate it so much. We love the cloud community, and I'm thrilled you're here. AJ, thanks so much. Please hit the like button, come back. We have to thank AJ for his service in the Marine Corps. AJ is a great guy. We're thrilled that you're here. Blocked out, learned a ton. I'm so happy. That makes me happy. And Tom Wall, thanks so much. We're thrilled you're here. Thanks, Christian. We're happy to help. Thank you, Collins. Peter, thank you so much. And Emmanuel, we're thrilled you're here. Anselm from my team, thanks so much. Thank you, Samir. And thank you, Lady Godiva. AJ, we're thrilled to see you here. You feel certified already? Wonderful, Huey. That's our point and our goal. You're more than welcome, Victor. Oh, sure, you're so welcome. Omar, we are so happy to keep providing content. We love doing this. Great job. And back to you and your cats. Thank you. I really do love my cats. Actually, Chris has a beautiful cat too. Another educating, still learning things with ease. I'm so thrilled to hear that. And Igor, we're so happy to help. As a current student, Mike has helped me land a career, and I'm so thrilled to that. And you're continually learning more. I'm thrilled to know that, Dino. Thrilled. That's our whole point. Change lives and get people hired. Would you suggest taking the solution architect first or the CCNA? I don't know what your goals are. Please join us on the How to Get Your First Cloud Job webinar tomorrow night, because your goals determine what you should learn and how to do it. Sanjeev, thank you so much. Please join us on that webinar tomorrow. It'll be a life-changing event. So thank you all so much. I'll see you all tomorrow in class. And please make sure you join that webinar. It is really valuable information that I want you all to know. Have a wonderful, wonderful night.